Welcome back to another video, and in fact in this video we're going to be doing a course on Git and GitHub. So today we're going to dive into Git and GitHub, which are two essential tools for any developers. Git is a version control system. It helps you track changes to your code, collaborate with others, and roll back if something breaks. Think of it like a time machine for your projects, where GitHub is a platform where you can store your Git projects online, which makes it super easy to share your work, collaborate with your team, and even contribute to open source projects. So in this course you'll learn the basics to begin with, what is Git and GitHub and Git Architecture, and the workflows and so on, how to set up Git and GitHub, and other basics like save your code with commit, push it to Git and GitHub, and then different ways of reverting changes. What if you need to get back to certain changes, how you would revert those changes, and there's different methods to do this depending on what you want to do. And then we go into further commands on Git and the file structure and so on, and in the course there's also a cheat sheet which provides many of the Git commands. And here is the end-to-end content of the course we are going to cover. So let's dive straight into it and get started. In this video, we are going to have a look at how we would integrate version control and collaboration tools for our projects. And this could be for our Python code, or it could be for Java, C, Swift, TypeScript, or any other programming language, any other code, HTML, websites. So we can implement version control for pretty much anything, and we can use collaboration tools. So a team of developers can access the same code from anywhere in the world. For version control, we will have a look at Git, and for collaboration, we will have a look at GitHub. At a high level, Git is a version control system. Git tracks changes to files over time. So Git tracks the changes you make to the files. So you have a record of what has been done, and you can revert back to specific versions should you ever have to. Git allows developers to revert to previous versions of the codebase when required. And Git has other features as well. For example, branching and merging. We will have a look at this shortly. Collaboration. Now, although GitHub is a collaboration service as well, by nature, Git does collaboration. So we will have a look at the differences with collaboration between Git and GitHub. Git also has history tracking amongst other features. So in a nutshell, Git is a version control system. It will take multiple snapshots of your project, and then you have multiple snapshots you can revert back to if you ever have to. And looking at GitHub at a high level, GitHub is a hosting service. It's a very popular programming resource used for code sharing. You can see GitHub as a social networking site for programmers that many companies and organizations use to facilitate project management and collaboration. So GitHub provides a platform for developers to host, manage, and collaborate on code repositories. It stores and manages Git repositories in the cloud with support for both public and private repositories. And GitHub can do other things as well, such as continuous integration and deployment, CI/CD, and collaboration tools amongst other features. And GitHub has become an essential tool for many developers and technology professionals because it provides a platform to showcase their skills, experience, and portfolio of work. And due to this, recruiters often turn to GitHub profiles when evaluating candidates. Also with GitHub, you can often reuse other people's work. Rather than creating your own work from scratch and vice versa, you can also share your own code with other developers. So as long as you adhere to the licensing terms that it is published under, you can copy the code from GitHub for your own use. However, just to bear in mind, not all code on GitHub comes with an open source license, but if it does, that license allows you to copy the code, modify it if you wanted to, and use it for whatever purpose you want. So in summary, you would need Git, which is a free and open source version control system, to manage your source code and make copies of it. And of course, it does other things as well. And when you want to collaborate with a team of developers, then that's when you would use GitHub to store all your code in the cloud, which is also a free open source cloud-based service for storing your code. And this makes it accessible from anywhere in the world. The second bullet point on this gives it away: store and manage Git repositories in the cloud. Let's have a look at what a version control system is. With Python, like any other programming language, version control is crucial to managing changes to your source code over time. Version control is needed for when things go wrong with your code. So typically, a version control system like Git provides the following capabilities. A version control system tracks and manages all of your changes to your code A version control system gives you the ability to store copies of the code as you progress through building your code. A version control system could be for your Python code or any other code, or it can be for your web design layouts or images or anything else for that matter. And a version control system promotes team collaboration where multiple developers can work on the same source code simultaneously without ever overwriting each other's changes. So it manages conflicts with changes for you as well. A version control system enables tracking of all changes, what changes were made, who made the changes, when the changes were made. This helps with debugging and reverting to previous changes seamlessly or easily. A version control system provides branching and merging capabilities. Separate branches can be created to work on bugs and features without impacting the main branch, and these can then be merged back into the main branch. I am going to be expanding on branching and merging in this video shortly. Another use case for version control system, backup and recovery. In the event of a failure, a VCS or version control system provides a backup of your code. It's not supposed to be there for a long-term backup solution, retention backup solution. It's a version control system. But in the event of a failure, a version control system, regardless, it does provide a backup of your code. Again, it shouldn't be used as a long-term backup solution, as it's not being built for that purpose. And there are other benefits to version control systems, such as they can be used for auditing and compliance, code quality, of course, version management, and other built-in features and tools. Now, there are three main types of version control systems. The first one is local, so storing different versions of a file into the local system. Downside to a local version control system are that a team of developers could not collaborate with locally stored files, and it's a single point of failure. Then there's centralized. With centralized systems, they were created to facilitate collaboration amongst developers. All files were stored on a central server and accessed from a single location, but this also introduced a single point of failure. If the server or group of servers became unavailable, whether due to server downtime, maintenance, or connection issue, access to files would be interrupted. So to address the issues with local and centralized version control systems, distributed version control systems were developed. In these systems, each user has their own complete repository. Client machines create a full mirror image of the repository, including its entire history. This ensures that all clients have a complete copy of the repository. And with a distributed version control system, if the server goes down or fails completely, a client can upload its complete copy back to the server. There is no real server as such in a distributed version control system. Well, there is and there isn't. There is a master repository which everyone uploads and downloads their files from. We will have a look at this because this is very much how Git works. So moving on to Git. Git is a distributed version control system. In Git, each user has a complete copy of the entire repository, including its full history. However, rather than teams pulling and pushing changes to each other, there is a master repository. So Git kind of works in a centralized fashion as well, and the master repository is usually uploaded to GitHub so everyone can get access to it, as GitHub is a cloud-based service available at all times. Now, all developers pull and push from the master repository hosted on GitHub. However, it doesn't have to be on GitHub, by the way. It could be on a server in your network as long as you have Git installed on it and have a copy of the repository. But GitHub is kind of best practice with it being available from anywhere in the world, amongst other benefits. And since it's free and open source as well, then why not use it? You do not need GitHub, by the way, to use Git, but you do need Git to use GitHub. Now, another reason why GitHub comes into play is there are downfalls with Git. For example, developers have found the distributed nature of Git difficult to configure, whereas a single central repository shared by developers seems to be the preferred choice. And now with everything in the cloud, this is where GitHub addresses some of those limitations with Git. So you can collaborate with just Git. You just need to install Git anywhere on your network and all developers can collaborate with it. But when developers need to access files from anywhere in the world, then it makes sense to host it on a cloud-based platform where all developers have access to it at all times from anywhere in the world. And this is where GitHub comes into play. Looking at alternative version control systems, if we type Git Alternatives in Google, it provides a mixture of Git Alternatives, and GitHub Alternatives as well. So as we have already gathered, GitHub is a cloud-based hosting service and it hosts Git repositories. So it serves a different purpose to Git, which is a version control system. Now Git is the most popular version control system and it's a distributed version control system, but there are also some of these as well. For example, Subversion SVN. This is another version control system which is commonly used in enterprise environments for projects that require strict version control and access management. Then there is Mercurial. I hope I've pronounced that right, but it's similar to Git. It is a distributed version control system. It's designed more towards larger projects and built for scalability. Although similar to Git, it has a different set of design philosophies than Git. Mercurial users typically use another service which is called Bitbucket or other platforms that support Mercurial. So Bitbucket is a GitHub alternative. Now looking at GitHub alternatives, we can see GitLab and Bitbucket. So GitLab is a GitHub competitor that also offers an open source on-premise version of their software. It's suitable for teams and enterprises looking for an integrated DevOps solution. It offers tools for the entire software development lifecycle, from planning to monitoring with strong CI/CD capabilities. And then Bitbucket, like GitHub, Bitbucket is also another web-based hosting service for version control repositories. Bitbucket is a platform that facilitates collaboration, hosting, and management of Git repositories. And Bitbucket provides great collaboration tools for granular access control and integration with something called Atlassian ecosystem for software development, project management, and team collaboration. Now this is a bit of a duplicate slide comparing GitHub, GitLab, and Bitbucket, but the key note to take away is that all three are popular web-based platforms for hosting Git repositories and supporting version control collaboration. So this slide is an overview of Git. It's a bit of a duplicate, but after this we will have a look at the Git architecture. Let's take a look at the Git architecture, as it's essential you understand the key areas and some of the associated commands before diving into Git. So you can call them key areas or workspaces. We can see in the boxes are the workspaces, and we can see in red are the commands. So these are some of the common commands. Of course, this is not an exhaustive list. I have one coming shortly. So starting at the top left, we install Git on our local computer. Then one of the first things we do is use the git init command. This does two things. It initializes a project to work with Git, as we can see in the green box on the right hand side, which is the working directory. Git init, by the way, stands for Git Initialise. So all the commands are in red, by the way, and the boxes are our workspaces. Now this has initialized and created a working directory. And the second thing Git init does, over here in the middle, it creates a new repository as shown in the brown box. So let me rephrase this. When we use the git init command after installing Git, Git creates the working directory, and it also creates a subdirectory called .git that contains all of the local snapshots. These are all of the commits we do and other metadata about the project, which is the local repository. So git init creates the working directory and the local repository. A repository is just a directory that is initialized with Git, and it can contain anything such as code, images, web content, or any other type of files. Now going back to the green box, this is the directory where we make our changes, and then when we are happy with the changes, we add these into something known as the staging area, and this is done with the git add command, we can see in red. Or we can use the Git RM command, by the way, which is git remove if we was not happy with the changes and wanted to remove the changes. By the way, you may recognize RM as one of the Linux commands, as Git was created by the same person who created Linux. Now the staging area, this is a temporary holding place where you choose the changes to include in the next commit. It gives you a chance to review the changes before you actually finally commit them to the local repository. By the way, it's best practice to make little and regular changes. So then we can review and then commit the staged changes to the local repository using the git commit command, which in effect takes a snapshot and produces a hash for the commit, which is a unique identifier of the commit, and you can add a comment as well so you know what the commit is. And the git commit command is essentially creating a point in time local snapshot of the project, which you can revert back to in the event of any issues. So we created the local repository using the git init command, and we can see this in the middle, the brown box, and this created a brand new repository But in a real world scenario, we may already have an existing repository. For example, a remote repository hosted on GitHub when a new developer wants to work on an existing project. And this is where they would clone the existing remote repository. So we could see the git clone command going from the remote repository, which could be hosted on GitHub or GitLab or Bitbucket or any of the other hosting sites. And it's cloning the entire project to the local repository. So rather than using the git init command, this is the alternative method using the git clone, cloning an existing repository, which in effect creates your local repository and your working directory on your local machine. And then on a daily basis or a weekly basis, when you make your regular changes, then we can use the git push and git pull commands. The git push command to push changes to the remote repository, or vice versa, we can use the git pull command to pull changes from the remote repository. So these are the basic building blocks of Git, and as a typical workflow, it will look something like this. You initialize a directory for Git, or you clone an existing one. You then add or change a file and add it to the staging area. You then commit the change to local repository, and then you push a file or change to a remote repository. And then on a regular basis, you are updating a local repository by pushing or pulling changes to the remote repository. So that's the typical workflow. Another part of Git which is important to understand is Git branches. So you can create different instances of your repository called branches. And a branch allows you to work on features and bugs without impacting your main branch. By default, there's only one instance of your repository called the main branch. I think it's also called the master branch. So master branch or main branch, and your main branch should be your main production branch, which is your stable code, and then you use other branches for new features and bug fixes. So you would typically use other branches for new features and bug fixes, which will provide an isolated environment for every change in your code base. So you can see a branch as a timeline of all your commits, and you can work on separate branches in parallel. So you can have a main branch, which is your main production code. I've got the diagram in front, so you can see the main branch is in green, and then you create another branch off it. You could create another branch off your main branch, and this will be a separate branch. So one for fixed bug, and another one for new major feature, and another one for new minor feature, or bug 1, bug 2, etc. And you could have feature 1, feature 2, feature 3. So you could have all these different separate branches. And then when the feature or bug fix is ready, you would merge these back into the main branch. Now on the bottom right, I have created the diagram again. So in green, these are all of our commits. So in effect, it's a timeline of the main branch. Now a separate branch has been created for the bug fixes, which has its own timeline, and another 2 branches in yellow and blue for features, which have their own timelines. And they all have something which is called its head, which is where the branch points to for its next commit. So the head is the reference to where the most recent commit in the current branch is going to be. And this is an important concept, in particular when working with Git Checkout, when you detach the head and when you are reverting the code. So the master or the main branch has its own head, but when you create a new branch, it will have its own head. So all of these are isolated from each other, and the next commit for each of these will point to their own heads or their own commits. This means all branches end up with their own timelines of commits. Eventually, we merge all of these together, and of course, it's simple to merge them on your local repository, but when merging them to the remote repository, where let's say a team of developers are working on, then you may need to resolve conflicts, which is, for example, when 2 developers have changed the same line of code and both are trying to merge back into the main branch. So most of the times, these kind of conflicts are resolved manually. You, as a developer, can resolve which change you want to keep. Now here are a few of the common branch commands. So using the command git branch without any additional argument will list all of the branches in your local repository. And to create a branch, you would use git branch followed by the name of the branch. And the star sign will represent the current branch, the branch you are currently on. We'll have a look at this shortly anyway. Once you have created a second branch, for example, then you can use the Git Checkout command, which allows you to navigate through branches. So now to switch between branches or to move heads, we use the Git Checkout command. Just for completeness, let's have a look at types of branches. So the main or master branch, which is the default branch, contains the stable version of your code. Then there's a feature branch, which is used to develop specific features, and once ready and tested, it's merged back into the main branch. And then there's the hotfix branch, used to fix any urgent issues with the main branch. So the hotfix branch will allow you to fix any issues without impacting or disturbing your ongoing development with your feature or release branch. And then there's the release branch, which is used to create a new production release. And once that's ready and tested, it's also merged back into the main branch. Now this slide is more of an exhaustive list of the Git commands. It's not all of the commands, but it's many of the commands. And I have broken them down into sections. So we've got the initialize and setup, and then commands for branching and merging, and then the staging area, remote repositories, view analysis, undo changes, and then tagging and stashing. So you can use these as a reference, and I will be using these as a reference as well when working in the live environment. Welcome back to another video. In this video, I'm going to install and initialize Git on the Windows 11 operating system. Now, if you are installing Git on a Linux or a Mac operating system, you can install it using these commands here. If you are installing it on a Mac, it's installed via Homebrew, and the command is brew install git. Otherwise, if it's Linux, it's installed via your package manager, and you can use the command sudo apt-get install git. But we are going to be doing it using Windows. And with Windows, we can use Google search. So let's search for Git. And the website we want is git-sem.com. And we've got download for Windows over here. And the one I want is the standalone installer. And I'm going to be using 64-Git for Windows setup. So that's going to download now on the right hand side. And now that it's downloaded, we can click it to install Git. And we can click on yes. Do you want to allow this app to make changes to your device? Now the one thing we can do is if we open up the command prompt, we can check if Git's installed. So all we do is type Git, and if we press enter and it's not recognized, Git's not installed. Now going back to the setup, we can press next for the licensing information. And next it's where should Git be installed. Let's stick to the default, which is C program files Git. And this page shows us what components to install. So we can see there's a few components here, but we are going to stick to the defaults on here and click next. This time it's asking us where should setup place the program shortcuts, and we will stick to the default. So we'll create a folder called Git, and let's click on next. Now on this setup page, which editor would you like Git to use? And it always gives us some information here. So it's saying the Vim editor, while powerful, can be hard to use. But Vim is the default editor of Git for Windows, only for historical reasons, and it is highly recommended to switch to a modern GUI editor instead. Now, if we drop this down, we can choose the editor of our choice. And in here, we can see lots of popular editors. We can see Notepad++, Visual Studio, Sublime, Atom, and at the bottom, we also see Notepad and WordPad. And I'm going to choose Notepad for this. So let's click on Notepad and click Next. Now, what would you like Git to name the initial branch after git init? Git init is the git initialize command, which initializes a repository. And if we let Git decide, Git uses its default branch name, currently master, for the initial branch in newly created repositories. But we can override it, and I like to override this. So I like to refer this to main as the main branch rather than the master branch. And by the way, a branch allows you to work on features and bugs without impacting your main branch. So you create your main branch. This is our default branch. The main branch is where our main production code is. But then, for example, when we are working on specific features and bug fixes, we create different branches. So we are not impacting our main branch. So that's what this is for. And in this case, it's just asking us what we want to name our main branch. It can be called the master branch, but I prefer the name main. So let's leave it as main and let's click next. Now, adjusting your path environment. How would you like to use Git from the command line? So we can use Git from Git Bash only, which is good for Linux and Unix users. And then the next option is Git from the command line and also from third-party software. And this is the recommended option. So this option adds only some minimal Git wrappers to your path to avoid cluttering your environment with optional Unix tools. And then it says you will be able to use Git from Git Bash, the command prompt, and Windows PowerShell, as well as third-party software. And then the last option is use Git and optional Unix tools from the command prompt. So here it says both Git and optional Unix tools will be added to your path. So unless you need these two for specific reasons, stick to the recommended option here and click next. Now, which secure shell client program would you like Git to use? So you can use the default, which is use bundle open SSH. This uses ssh.exe that comes with Git. And then there's a new option, use external open SSH, and this uses an external sh.exe, and with this Git will not install its open sh binaries but use them as found on the path. And you can read what it says here, but let's stick to the default, use bundled open SSH, and let's click next. Now, which SLTLS library would you like Git to use for HTTPS connections? So the default is use the open SL library. Server certificates will be validated using the ca-bundle.crt file. And then we also have the option use the native Windows secure channel library. So in here, server certificates will be validated using the Windows certificate store for when you have a company's internal root certificate that you want to use. And this option is good because it allows you to use your company's internal root certificates. For example, using Active Directory domain services. But we are going to use the top option, use the OpenSH library. Let's click next. Now for sure, this is the option to use for Windows. This is the recommended setting on Windows, but this is the recommended setting on Unix. And then there's the as is. So Git will not perform any conversion when checking out or committing text files. So by the way, it does say how should Git treat line endings in text files. And we will stick to the recommended one for Windows here. Let's click next. Terminal emulator do you want to use with your Git bash? And then again, we will stick to the default. Use min tty, the default terminal for MSYS2. And as usual, it tells you more about it over here. Or we can use the Windows default console window, but just to bear in mind, it says it has very limited default scrollbacks. Needs to be configured to use a Unicode font in order to display non-ASCII characters correctly. So it's got some limitations. So let's stick to the top one and click next. Now this is about the default behavior of git pull. What should git pull do by default? We will stick to the default, which is fast forward or merge. So fast forward the current branch to the fetched branch when possible. Otherwise, create a merge commit. You can also choose rebase and rebase the current branch onto the fetched branch if there are no local commits to rebase. And rebase is the equivalent to a fast forward. So the first option. And then the last option is only ever fast forward. So this will fail if fast forward is not possible. Again, let's stick to the default, fast forward or merge. And now this setup page is about which credential helper should be configured. And this stores all of the credentials, including the credentials to connect to GitHub and other websites and other applications as well. So this uses Git Credential Manager and this does not. So let's stick to the default again. Click next. So here are some features we can use. Enable file system caching, and this is a good thing because it provides a significant performance boost. And then this is to do with symbolic links, enabling symbolic links. So you can do this if you wanted to, but we will leave it as disabled. Let's click next. Now it says here, these features are developed actively. Would you like to try them? So the first one is enable experimental support for pseudo consoles. And it tells you here this allows running native consoles, programs like Node or Python in a Git bash window without using Wimpy, but it's unfortunately not quite stable yet. And then this is enable experimental built-in file system monitor. So it can speed up common operations such as git status, git add and git commit that are inside work trees that contain many files. So this is a feature to speed things up. So that was quite a few options, but we have got there and we can click on install to install Git. So now Git has now installed, we can click on finish. Actually, we can click on launch Git bash as well and view the release notes. And let's click on finish. So it will open up Git bash. Let's open up the release notes. And in the release notes, we can see we can have a look at the known issues. We can have a look at new features, including bug fixes. So that's in the release notes if you wanted to have a look at those. We are going to skip this and jump on to Git bash. Actually, before we use Git bash, let's go back to the command prompt and type git. Right, it's still not recognized it because we need to start the command prompt again and click on git. And now it's recognized Git. And over here it says these are the common Git commands used in various situations. So we can see some of the commands we can use. Start a working area, work on the current change or examine the history and state. Now actually, before we jump onto Git bash, if we have a look at the start menu, we see three options. So Git bash emulates a bash environment on Windows. It lets you use all of the Git features in the command line and also many of the standard Unix commands. So if you are a Unix user, you would use Git bash. Otherwise, for Windows, it's Git command line, which is the Git CMD And this is basically using the Windows command prompt with the Git commands. So you can use all of the Git features through the command line. And again, it's useful if you work on Windows commands and you work on Windows. Now, finally, there's the Git GUI, and this has minimal features, but let's have a look at it. It's got create new repository. It's got clone existing repository. It's got open existing repository. If we have a look in here, it's got the same thing, new, clone, and open. So the Git GUI is there to create, clone, or open repositories without having to do anything with commands. So it's got minimal features, and that's why we are going to use Git Bash. Now, when you install Git, the first thing you need to do is set up a username and email address. And these are needed, both of these are associated with each commit. So every time we commit Git, these two pieces of information are associated with each commit. So the way we do that is git config -- global user.name, and then we specify our name inside speech marks and press enter. Now for user.email we could do the same thing, but it's user.email instead of user.name. And I'm going to use a fake email here, so this is not real, and let's press enter. Now if we use git config -- list, we can see all of the current configuration settings. So if you want to see what your current settings are, you run the git config -- list. So in here we can see things like user information, repository settings, color preferences, and right at the bottom here we can see my username and my email address we have just set up. The next thing we want to do is initialize a repository. So we can either clone an existing repository if we are working on an existing project, or we can create a brand new one, and we are going to create a brand new one. But the first thing I will do is create a directory. So if I do a pwd, just to understand where I am in terms of my working directory. Now let's use the mkdir command to create a new directory, and let's call it my git. So let's change directory to my git, and we could specify the full path and then my git, enter. And finally, let's do a pwd to make sure we are in my git, which we are. So it shows my git over here. Now we can initialize Git inside the new folder, my Git, and we do this using the git init command, which initializes a new Git repository in the current directory. So it's done that instantly, and it's telling us initialized empty Git repository, and it tells us where it's initialized the empty Git repository. And if we see here, it's created a hidden directory called .git, named .git inside the current directory. And this Git directory contains all of the necessary files and subdirectories that Git needs to store repository, metadata, and object databases. Maybe if we do a pwd here, sorry, not a pwd, a dir, and we see nothing actually because it's a hidden file. What we can do is open up the folder. Now if I go to this PC, C drive, users, JAF, and then my Git, it should be in here, but it's a hidden file. So if we go to view, options, and then view, show hidden files and folders, apply, OK. There we are, so we do see it now. And here's all the hidden information in here. Now the next thing we can do, if we go back to Git Bash and we do a git status, this is a command we will use often. It's a very common command used with Git because you need to know the status of Git, the status of your repository. And what we can see here is on branch main. So we did call the default branch main, and we can see it says no commits yet. There's nothing to commit. Create copy files and use git add to track. So it's basically saying add some files in here first. So this provides a summary of the current state of the working directory and the staging area. It displays which changes have been staged, which haven't, and which files are not being tracked by Git. So using the Git status helps developers understand what changes have been made to the working directory and what steps are needed to prepare these changes for a commit. And that brings us to the end of this video. So that's how we install Git on Windows 11 and how we initialize a new repository, and just have a look at the current state of the repository using the git status command. From the first part, we have now created a new repository called mygit, and now we are ready to add some files. But before we start tracking the files with Git, I want to go over the two-step process with Git and Git files. So when we commit Git changes, there is a two-step process in doing so. We first stage the files so that they are added to the staging area. And then second, we commit them to the repository, which in effect is a point-in-time snapshot. And staging enables us to stage changes we want to actually commit. Staging is especially important when you're working on multiple things on your code at the same time. So for example, whilst you're working on the main code, you need to update a bug fix. So you stage the changes for the bug fix only, and then you commit the change for the bug fix with its own commit message, such as bug fix to resolve, let's say it's an authentication issue, so bug fix to resolve authentication. And then continue working on the rest of your project. So it gives you that flexibility to frequently update your changes in small increments and provide each of them with their own commit message. So this way you have an audit trail of what commits are for what changes, which is actually best practice. Staging the files so you can see it as getting the files ready for a commit also allows you to review the changes you're about to commit, and then you can choose which files are going to be committed and which files are not going to be committed. So for example, you might have a file of your notes, so you make notes of your different codes and your different files. Maybe that file you don't want to commit, so you don't go ahead with committing that particular file. Before we get into the command line, it's also useful at this point to know about the different states of a Git file. The first one is the modified state. So in this state, changes have been made to the file, but they have not been committed to the database yet. Then the next state is staged. We've just spoken about stage. In stage, you have marked a modified file in its current version to go into your next commit. So you have got the file ready to be committed, and this is the staged state. And then you have the committed state. So in this state, you can see it as the data is safely stored in your local database. So it's been committed. Or in other words, a snapshot has been taken of the Git repository. So in this state, you have a committed snapshot of your repository, which you can revert back to if you have any problems in the future. Now I wanted to share the different areas of Git. So in these states, what is occurring? So you have the working directory. So you make your changes to your files here, and these files are not yet tracked by Git. And then there's the staging area. So here you can add changes from the working directory to the staging area. And this process occurs when you use the command git add. We'll be doing this very shortly. The git add command also enables tracking of the files. And then there's the repository. So using the command git commit, all of the changes in the staging area are committed to the repository. This process is also flexible, so you can add changes from all files or selected files or changes from a specific file. Now the committed state you can also see as an unmodified state because everything has been updated. Git knows about the latest changes, and to think about it, when it's committed, it's kind of like an unmodified file or unmodified repository. So you can see it as unmodified as well, as Git has all of the changes. It knows about all of the latest changes. So I almost feel like adding the term unmodified in there after we do a commit as well, as Git is up to date with everything. It knows about everything. So you can see it as the unmodified state as well. We'll now add files, and theoretically we can add any file at all in here. So from Python files to HTML files to images or whatever you want. But I will add two simple text files. So you can do that from the command line. We can type touchmyfile.txt. We can also add another file in here as well, or if we press enter, I can add a file manually in here, but you can see myfile.txt has been added as we have just typed it into the git bash command line. But I can also do this manually as well from here as well, from Windows Explorer. So I can do another text file, and let's call this one myfile2. Now if we go back to git bash, a common command we will always use is git status to verify the status of the Git repository. And this is the status, so it's showing us we're on the branch main because I changed it to main when we first installed it. By default it's called master. There are no commits yet, but there is two untracked files. One we added from git bash and the other one we added from Windows Explorer. And it's saying nothing added to commit, but untracked files present. So it's telling us there are untracked files. We can also, by the way, do a dir from here as well. We can see them inside here because we are already in the my-git repository. So the dir and git states command will confirm the status of files. So the dir command will show us that the files are present if you're not using Windows Explorer. So it tells us the files are not yet being tracked. They need to be tracked so Git knows about these files and can monitor them. So let's go back to tracking these new files. And when we use git add, we can do git add followed by a space and a period to track all of the changes we have made. Or we can do git add followed by the file name to track individual files. But we are going to track all of the files, so git add space period and then press enter. And then we will do git status again to verify the status of the Git repository. And we can see it's changed from red to green. which means it has been staged and it's now tracking the files. Whereas previously it was red because it was modified, but it was not staged. Now we've got the files ready for a commit. They're staged in the staging area. And git commit is a git commit. It creates a point in time local snapshot of the project, which you can revert back to at any time. And to commit the change, it's git commit followed by an M for message. And the message is really important because you describe what exactly you are committing. So for me, it's adding my file and my file 2 to my Git. So make sure you describe your commit message as clearly as possible so you recognize it in the future. Just in case you need to revert back to it, you know exactly what that commit was for, that point in time snapshot, the commit. So now if I press enter, and the one thing I missed there is the hyphen. So it's git commit hyphen M. So it's got to be a hyphen before the M. If I add that in there, press enter again, and we can see the status there. It says 2 files changed. So to confirm things as usual, we use the Git Status command. And now we can see we're at the committed state. So everything is up to date. Nothing to commit, working tree clean. So Git is telling us it knows about everything. Everything is clean, it's up to date. So next, if I remove and add some files in here, let's say we remove myfile.txt, and let's add index.xml and mypyfile.py and do a git add. Period. Maybe we should have done a git status before git add period just to have a look at the status, but we will do one now anyway. And they have gone green again because we just did a git add period and they're now tracked and staged. Now let's do a git commit -m, added and remove some files in here. Obviously you want to be more specific than that, and this will commit the new changes. And let's do a git status again just to confirm everything is up to date again, which it is. Nothing to commit, working tree clean. So that's how you make changes and use git add and git commit. Of course you can make changes within the file as well, and Git will track those. Let's do that now, but I'll also show you how to combine git add and git commit as one command. So now let's suppose I'm making a simple change to a file, my file 2 in this case. So let me open that up and add the line new changes, save it and close the file. And if I do a git status, we can see the file has been modified and it's showing in red. Now from here we would usually do a git add and then we can specify the file name, or a git add and period to add all the changes. And then as the second part we will do a git commit. But let's say we want to just make this simple change as we have done now and combine these two processes. So git add and git commit. And we can do that using an O flag followed by the file name like this. So we do git -m. Let's say we specify the message, made some changes to my file 2, and then it's -o, and then it's the file name myfile2.txt. It's opened up the file for us too, but it has committed the file for us, and we can see it says made some changes to my file 2. One file changed, one file insertion. So let's do a git status to confirm everything is up to date, and we can see everything is up to date, nothing to commit, working tree clean. And that's it for this video. That's how you add changes to the staging area, and that's how you commit them. Now that we have done some git adds and git commits, and we have taken some snapshots of our projects. So that's the git commits. The git commits are the point in time snapshots. It would be useful to be able to see what we have done in case we do have to revert back to these commits, as after all, that is what Git is there for. And each snapshot or commit has an identifier, also known as a hash. We will have a look at this, and we will be able to see all our commits for a particular branch. Our default branch is called the main branch, as I changed it to the main branch, but by default when you first install it, it's called the master branch. I'm going to add some more changes to my file 2. Let's call it more changes. Save and close the file. Now let's do a git status, and it shows us my file 2 has been modified. So let's do a git add period, and git status again. This time it should convert into green, and we can see every time we do a git status, we can see we are on branch main, the main branch. And the next thing we want to do is a git commit. So we'll do a git commit -m and call the message some more changes. And let's press enter. And we see one file changed and 2 insertions, but the main bit I wanted to show is the identifier. So we've got the commit identifier here. It's got 7 characters, AEF3798. We need to know this because this identifies the commit, and also when we are reverting changes, we may want to revert to this commit. So we need the identifier. It's longer than this, so this is the 7 characters we can use, but the full identifier is much longer, which we will see next. So the main command we need to see all of our commits is git log. So this is the log of our commits. When we run git log, it will show us all of the commits, or in other words, point in time snapshots from the most recent at the top to the oldest at the bottom. So what we see here is our most recent change. So we can see the message, some more messages, some more changes, should I say. And then we have the date this commit was committed. And then when we first set up Git, I had to specify a name and an email address. So we can see that over here, the author, my name and email address. And I used a fake email address. That's not a real one. And then we have our identifier, the commit identifier. We can see it's much longer than the 7 characters, but we just need the 7 characters when we are reverting changes or we are checking out to that change. We can also see where the head is as well. So the head is in the main branch and it will be following the timeline of commits on this branch. So when we do our next commit, it will follow this timeline. So oldest to newest commit from bottom to top, and the next commit will be, of course, it will be over here, and these will shift down, because that's where the next commit will be going. It will be following this timeline within the main branch. So I have about 4 commits, but let's say you had lots more commits. Let's say we had 100 commits. We can use another command, git log -- online, to streamline each commit so that we see more of them. We see more commits and each of them on a single line. It helps us see more of our commits if that's what we wanted to do. So we can see which one we wanted to revert back to. Spelling error, I missed the E. And let's press enter again. So here we are, we can see all of our commits. We can see them on a single line. So we can see the identifier followed by the message. This is why you need to ensure the message is very clear so you know what that commit was there for. Also, if you have too many commits and only wanted to see, let's say, the last 20, we can do that as well using the -n option. So that would be git log -one line -n, and let's do 2 to see our last 2 commits. And there we go, it shows us our last 2 commits. Of course, in a real world example, there may be hundreds of commits and you want to streamline these to the last 20 commits. Now, having a look at the documentation. So if we go to Git and have a look at git log, in here there are a lot more options to do the filtering. For example, if we hover down and we have a look at the options, we can see things like the log size, or something even more relevant, maybe the commit limiting features. For example, since date or after date. So show commits more recent than a specific date. Or you may want to do show commits older than a specific date. Or what would be really good is the author information. So you may want to see all the commits done by a particular developer. And you've got more advanced things as well, like the committer pattern. Limit the committer output to the ones with author. Committer headlines that match the specified pattern. So you've got lots of granular options in here for really narrowing down how to find the specific commit you are looking for. So I mean, the commits are endless, so you can look for commit formatting. So using pretty print the content of the commit logs in a given format. So there's so many options in here. So that's how you use a git log command to view your commits and to search for commits as well, using very specific filter options like the date and the author, etc. And in the next video, we'll have a look at how to go back to a specific commit using commands such as revert and reset and Git Checkout, etc. and the differences between each of them. Welcome back to another video. In the previous video, we had a look at the git log command to view the history of our commits. So all the point in time snapshots we've taken, which are the commits, we had a look at them through the git log command. Next, I want to talk about the Git Checkout command, because that's what we are going to use to revert back to these previous commits. So we can revert back to them to view our changes in those older commits. We use Git Checkout for a couple of things actually, and I'm going to go into more detail about this later on in the video, but we use it to switch branches, and the second thing is, as it says over here, to restore working tree file. So restoring the working tree file is going back in time to the previous commits, so reverting the state of the working directory to the previous commits. So in this video we're going to focus on the latter one, restore working tree file. So Git Checkout will revert your working directory to specific commits. Now if we have a look in the middle of the screen, there's a main branch timeline. So this is my branch, it's called the main branch, and this is my timeline of commits. And we have 4 commits here. In the middle of each box we can see the identifier of each commit using the first 7 digits. and the head is at the end, which is pointing to where the next commit will be. And as we can see, these commits are my actual commits, by the way. And I've taken a screenshot of the previous video of the command line console. We can see in black. And this is the Git log, and this shows us all of our commits. So I have 4 commits, and this is a timeline of our commits. And we can see the identifier of each commit as well, using the 7 digits. And the head is at the end, which is pointing to where the next commit will be. Now, when we do a Git checkout, followed by the identifier, this will revert to that commit, but also detach the head. The head is detached. It's now in a detached head state. This means the head pointer is not pointing to a branch. So it's no longer pointing to our main branch. Instead, it's just pointing to a specific commit. Usually the head points to the latest commit on the branch we are working on. And when you make new commits, they are added to that branch. In our case, it's the main branch. So what we can see is if I do a Git checkout and we use the 43D0070, the second commit in our timeline, which is on the left, is added and remove some files. This in effect takes you out of the main branch timeline. So in effect, it's being thrown off the main branch and it's not associated to any branch. And if we do a new commit, it will point to the end of this commit. So it's not associated to any branch. So why would we use Git checkout and the implications of a detached head state? So Git checkout is good for temporary experimental work. So you can experiment on previous commits. So you can make changes here and nothing will take effect, but bear in mind any commits you make whilst you're in a detached head state will not be associated to any branch, which in other words, they are known as orphaned commits. The commits can also be lost if you check out to another branch or you commit changes whilst in this detached head state. However, if you do like the changes you have made, there is a method to get this into a branch, which we'll have a look at. So we are now on Git Bash, and the first thing I'll do is check out my logs. So git log -- one line. And I'd like to go back to the very first commit I did. So this one here. Let's copy that one. The reason being is I added my file and my file2 to my Git. But if we recall, we did not have the index.xml file, or we did not have my py file.py. We just had my file2 and my file. So if we go back to Git Bash and we do Git Checkout, and now if I paste in my identifier and press enter, note on the right hand side, and we can see that the files have disappeared and we only have my file and my file2. So everything has gone back to the state of this commit. So whatever state the commit was in, we're in that state now. So my file, my file2, and if you have many other files in here, for example, all of the changes within the files will be at that particular state. We can also do a dir from here as well. It will show us my file and my file2. And we can see it says Git checkout and it gives us the identifier, and then it says no switching to, and then the identifier. But then it says you're in a detached head state. You can look around, make experimental changes and commit them, and you can discard any commits you make in this state without impacting any branches by switching back to a branch. If you want to create a new branch, retaining commits you create, so if we create commits here and we want to keep them, you may do so now or later by using the -c with the switch command, and then it gives us an example, git switch -c new branch name. Or you can undo this operation with git switch hyphen, and it shows us that the head is now at this identifier, added my file and my file2 to my Git. So this is almost the start of a new timeline. However, this is not attached to any branch. By the way, the git switch -c new branch name is a new way of doing it. We can also do it with a git checkout -b new branch name as well. And I'll describe the differences between the two at the end of the video. But we can still do a git status from here. And again, it says nothing to commit, working tree clean, and it tells us the head is detached. So instead, let's make a change to a file. Let's open up my file2, test my changes in a detached head state. Let's save and close the file. And now we will do git status. So we have a modified file. We can do a git add myfile2.txt, enter. Now this will add it to the staging area. Finally, let's do a git commit -m, give it a message. Test some commits in a detached head state and press enter. So it's always reminding us we're in a detached head state, so it says it over here as well. And if we run a git log from here, and we can see we have 2 commits in here now. The first commit is the one that we reverted back to, and this is the new commit we've just done now. Again, this is a detached head state and it's not associated to a branch. This is not the way we do version control. Version control is associated to a branch of commits. This is for experimental use only. Actually, if we do a git log, let's do a git log without the hyphen online. And usually in here we see the branch it's associated to, but we don't see anything. We just see the head. So now that we have played around with this commit in a detached head state, the way we revert back to a branch is with the command Git Checkout followed by the branch name, which is main in our case. And Git is quite good with information because it tells us, warning, you're leaving one commit behind, because we made a commit and it says not connected to any of your branches, and it gives us the commit identifier. This is the identifier up here, which my message was test some commits in a detached head state. And then it says if you want to keep it by creating a new branch, this may be a good time to do so. And then it gives us the command how to do that. So git branch and then new branch name followed by the identifier. Finally, it says switched to branch main. And we know we have switched to branch main because we can see on the right hand side, my index.xml file is back. And my file 2 should not have that comment I left inside it. So it's gone back to new changes and more changes. And it's removed the comment about the detached head state because I left a comment in there earlier. And of course, you can do a git log --1 line to verify I've got all my commits back, my 4 commits, which I have, and I can see we are in the main branch again as well. So this is one way of saving the changes to a new branch, but I've got another way as well. If we do a copy of that again, so if we copy it, let's go back into this detached head state. So git checkout, and then let's paste it in. Made a mistake, I used F instead of a G. So git checkout, and then let's paste in that identifier. I don't think I copied it the first time round. Let me do another one. Hopefully, third time lucky. Let me type it in instead. So we are checking out back to this commit in a detached head state. Now we can see on the right hand side we're back to my file and my file 2. Let me double click my file 2. So I have opened up my file 2 again. Test changes in a detached head state. Let's do a file and save here. So let's save the changes and let's do a git add myfile2.txt and let's do a git commit -m and leave a message. Testing changes in another detached head state. We can do a git log as well from here. Git log --1 line. So you can see the 2 commits, and the new commit is this identifier here with my message. So traditionally, the way we used to do this is using git checkout -b and then the branch name, my_branch_2. But there was a lot of confusion with the git checkout command. So there is a new command as well, which is called the git switch -c command. So let's use the git switch -c command. And what this does is the git checkout -b command is effectively a shortcut for 2 separate commands. So it's a shortcut for git branch, which creates a new branch, and for git checkout followed by the branch name, which switches to the new branch. And the word checking out, by the way, means the head now points to this new branch. Or we can do this with a git switch -c command and a branch name. So git switch -c my_branch_2. And this will do the same thing. And I'm going to talk about the differences between git checkout and git switch next. So let's press enter here. Now it's telling us it's switched to a new branch my_branch_2 using the git switch -c command. And if we do a git log from here, we can see our 2 commits. So added my file and my file 2 to my git. This was my very first commit. And then my second commit, which we did in a detached head state, is testing changes in another detached head state. And now it shows us the head is pointing here within my_branch_2. So that's how you retain changes in a detached head state and move them into a new branch. Next, I want to talk about the 2 commands, git switch versus git checkout. So the git switch -c followed by a new branch name for a new branch. That command combines the creation of a new branch and then switching to that branch in a single command, which is very similar to the git checkout -b new branch name command. And the reason for this is git switch is a newer command than git checkout, and due to git checkout being used for multiple things, it was a little bit confusing. For example, it's used for checking out to a specific commit, it's used to switch branches, and for file level operations, where git switch is used for one sole purpose, which is to switch branches. So that's its sole job, and because Git Switch has only one job, it's less error prone as you don't accidentally check out commits or modify files. And that's it for this video. That's how you use the Git Checkout command to revert to previous commits, and that's how we exit the detached head state back into a branch, or we exit a detached head state and retain the changes, saving them to a new branch. Next, we will have a look at the git amend command. When we do a git --amend command, it will let you replace the previous commit. It combines the staged changes with the previous commit to a new commit, and you can only use it against the previous commit only. In other words, the last commit. So it is a nice, convenient way to modify the most recent commit. The key thing to take away here is that it replaces the previous commit. So the commit will no longer be part of the timeline, and this new commit will take its place. And here I have got some commits. So we've got commit 1, 2, 3, and 4. And let's say the last commit, commit number 4, we made some mistakes, or we need to add some changes, or we need to update it with some changes. So we make some changes to it, and then we do a git add and git commit --amend. So we amend it, and the new commit is a brand new commit. So we can see it's 1, 2, 3, and 5. So 4 no longer exists. Commit 5 has replaced commit 4. Let's have a look in PyCharm how this works. So I'm back in PyCharm on my main branch. I've got my file open, my file 2, and I've got some changes in here. If we do a git log --one line from here, we can see our commits. And my most recent commit is this one here, AEF 3798, and it's called some more changes. So that's the message. Now let's say, for example, I missed something and it was in my file 2. So go to my file 2 and I add further changes, and we do file and save, and maybe we add my file 1 back in as well. So I missed adding another file as well, my file. So I made changes to my file 2 and I've added my file as well. So if we do a git status from here, we'll see there's a modified file and a new file that's untracked. So from here we can do a git add period to get these changes staged. Now that we have made these changes, let's say for example this last commit here, AEF 3798, some more changes. We want to replace this change rather than committing it to a new change. So the way we do that is git commit --amend and -m for message, and then I can specify the usual message in here, amended further changes and added my file. And maybe I can put in brackets amendment commit or something like that. And let's press enter. So we have made the change, and if I go back to git log --one line, what we can now see is the most recent commit has now been replaced. So this AEF 3798, it's been replaced by this commit here, A02C9E0. So this commit no longer exists, it's been replaced by this commit here. We can see the previous commits, they're all exactly the same, it's just the last commit has been replaced. So this is a good way of replacing the previous commit because you forgot something, for example, and you wanted to make some more changes, and replacing that commit with a new commit, rather than creating new commits. It may be a more streamlined way of managing your commits. And I guess this keeps your commits to a minimal. So rather than creating additional commits, you can just replace your last commit instead. I want to talk about another undo command, so to undo changes, and that's the git reset command. So the git reset command resets the head. It's used to move the current head and potentially branch pointer to a previous commit, which means it undoes changes made after that commit. And because you are modifying the commit history, it's safe to use with local changes, if you're sure you want to do this of course, but it can cause conflicts if shared with others. To be honest, all these undo commands, you have to use them with caution, because you are undoing something and you could potentially lose the work. So using the reset command, it's good for undoing recent commits that you don't want to keep or need anymore. So it may be good to use to clean up your history. So for example, you have too many commits and you are cleaning up your history. So if we have a look at an example, I've got 4 commits, 1, 2, 3, and 4. 4 is the head, and the next head will be following on from 4. So let's put H in here for the time being. But let's say we wanted to repoint the head to a previous commit over here, to commit number 2. And this means these 2 commits, number 3 and 4, are moved off the branch timeline, and any new commits will be created following this commit. And that's simply it, that's a git reset. So now we have moved the head over here to commit number 2. And this means the new timeline starts from commit number 2. And any new commits will follow this timeline. So the new one will be over here, and it will be 3. Well, Maybe not 3 because 3 is the old commit. Maybe 3b for example. So they all have a commit identifier which is completely unique. So be cautious using it as you are moving the history. And the tricky bit with git reset is even though you're moving ahead to a previous commit, your working directory stays the same. So it will reflect the last commit. So when we reset to a previous commit and do a git status, we would see all of the changes that we need to add and commit that were part of the commit we have reset from. So for example, if we reverted from commit number 4 to commit number 2, then in the working directory, we would see all of the changes that need to be committed that were part of commit number 2 and commit number 3. So if you add and commit from commit number 2 without doing anything else, you would add a new commit which would have the same changes as commit number 4 again. By the way, there is 3 types of git resets as well. There's a soft reset, there's a mixed reset, and there's a hard reset. With the soft reset, it moves ahead to the specified commit but leaves the changes in the working directory and staging area. It's as if you had not committed those changes yet. And then the mixed reset, which is the default by the way, it moves ahead to the specified commit and unstages the changes but leaves the changes in the working directory. So the changes appear as uncommitted modification. And then there's the hard reset, which is the most sensitive one and you have to be cautious with it. So the hard reset moves ahead to the specified commit and all changes in the working directory and staging area are discarded. Obviously this is deleting files, so you have to use it with caution. So with the mixed one, because this is default, which moves the specified head to the commit and unstages the changes, but it leaves the changes in the working directory. So the changes appear untracked and uncommitted. And with that said, even though you move the header to a previous commit, your working directory stays the same. So if from that point we did a git add and a git commit, it will reflect the last commit again. Git reset is a nice method to clean up your commits when you have too many commits. We combined commit 3 and 4 into a single commit, but imagine you had 20 commits and the last 9 were all minor updates. So commit number 11 to commit 20 were all very small updates. So it would make sense to combine them all into a single commit before you share your work with other developers. That's one use case of using git reset. Now we are back on git bash. I want to have a look at the git log --one line command. And this is where I can see all of my commits. So my latest commit is this one here, A02C9E0. Amended further changes and added my file. And I made a note to say this is an amendment commit. Now let's say for example these 2 commits here, I do not want them anymore. And I want to go back to 43D0070. So this one here. So if I copy the identifier and then we do a git reset and paste that in, I can press enter now. And again, the type of reset this is mixed reset. So this is the default where it moves the head to the specified commit and unstages the changes. So that's why this change is unstaged. But it leaves the changes in the working directory. The changes appear as uncommitted modifications. So I can make some further changes in here. So if we recall as our last change previous to this change, the amendment change, we created this line here, further changes. So with git reset, it's repointed the head, but we still have all of the changes in the working directory. So we still have further changes. And I can make other changes as well in here and file and save. We can do a git status on here now. And now we can see my file 2 has been modified and it's untracked. So we can do a git add period. Now we can do git commit -m and the new message will be new changes following a git reset. Let's press enter. Now if we do a git log -one line, and we can see these 2 commits are exactly the same as these 2 over here, but these have gone. These 2 commits here, they have now gone. So my new timeline started with this commit here. This is the head. This was the head until we made our last change. So this is the latest commit we just did now. These commits have gone. Now with Git, it doesn't remove things permanently unless we forced it. There is a way to get these back, but they are off the branch timeline. There is a way to recover them from Git. Next, we will have a look at another undo command, git revert. Now we just had a look at git reset, which is a bit drastic of a thing to do because it removes history, especially the hard reset. So instead, if you use git revert, when you revert a commit, Git creates a new commit, and this new commit is the reverse of the reverted commit. In other words, imagine your last commit, you create some files with some code inside them, and let's say you wanted to remove these files, but not permanently in case you need them in the future again. So instead, if you use the git revert command, it will undo these changes and create a new commit, but the original commit will still be preserved and in your timeline, so that you can go back to that commit just in case you needed those files with the content inside them again. And let's say we wanted to undo all of the changes that were made to commit number 4. So all of the changes to commit number 4, we wanted to undo them. So what we do is git revert on commit number 4, or you can also do git revert head, which is the same thing. It will revert commit number 4, and what will happen, it will create a new commit, commit number 5, which is effectively a reverse of commit number 4. It's commit number 4 before all of the changes were committed to it. So it's undone all of the changes and it's created commit number 5 from it. But this does not remove any of the history, so we still have commit number 4. And by the way, with all of the changes we are undoing for commit number 4, it can be a copy of commit number 3. But we don't want to go back and reset to commit number 3 and lose the stuff we have of commit number 4. We rather preserve commit number 4 and create a new commit instead. So as we can see, git revert is a lot more safer than git reset because it preserves the history. It's a perfect method to use when reverting changes that have already been pushed to a remote repository. So when you are collaborating with other users, you don't want to reset back. That could cause conflicts, which could be very difficult to resolve. It's safer to revert the change instead when you're working in collaboration with other developers. So git revert is the safest method to use when you are comparing git reset to git revert. Now the last one we wanted to have a look at is the git revert. So again, if I make some changes here, save changes and have a look at our git status, I can see my file 2 has been modified. So let's do a git add and a git commit changes to my file 2. Now if we have a look at the logs, we see changes to my file 2 here. So that was this change over here. A new change. So we added this as the new change and we committed the change, which is this one over here. Let's say we wanted to revert that change, so we can do a git revert. I think the command is head, like this, if we press enter. And I have a message over here, hint, waiting for your editor to close the file. And it's opened up a file saying revert changes to my file 2, this revert commit, and it's given us the commit identifier. Please enter commit message over your changes. Lines starting with hash will be ignored and an empty message aborts the commit. So I'm going to type my reverted commit, Ctrl S to save this. Let's close the editor and let's see what that has done. If we do a git log again and have a look at the git log, and we can see our new committed identifier, and this is the head now, revert changes to my file 2, and we can see all of the older commits are still preserved, so we can see all of them over here and they're all over here as well. One last thing I forgot to do is have a look at my file 2 to confirm the change has been reverted, and in the previous commit we added a line called new changes which has vanished, so we can see it's undone the changes and created a new commit, so the git revert has worked perfectly fine. And that's it for this video. So we've had a look at a git reset and a git revert. Git revert is a lot more safer, so always try and use the git revert unless you wanted to remove some history, in which case you can use a git reset. In this video we will have a look at how to unstage a file in Git and ignore a file as well. So what if you did not want to include a certain file in your repository? For example, if we had notes that had been created to let the team know about weekly project updates or something similar, and then we accidentally staged these files. So how would we unstage a file and we keep files in our directory without them being tracked? So let's take a look at this. So the first step, I'll create a new file called my_notes, and in here I'll put some notes in my notes for my project. Let's save the file. Now a git status will show there's an untracked file. So if we do git status, so we can see my notes.txt is untracked. And now if we do a git add my notes.txt to add the file to our staging area, and let's say we accidentally added this file and did not want to really add it to our staging area, and now this file has become a staged file, which we can confirm with the git status command. And doing a git status, we can see the file is now in green, which means it's staged. And what we can see over here is it says use Git Restore to get the file unstaged. So Git Restore -- staged and then the file name to unstage the file. So we can do this, Git Restore -- staged, and then it's my_notes.txt, And now if we do a git status, we can see the file has been unstaged again. However, we can easily accidentally re-add the above file again to the staging area. So how do we ask Git to ignore the file altogether? To ignore the files completely in the working directory. For example, it's a file for your notes, just like the file we have here, that you don't need to create commits for. For this, we can create a .ignore file in our repository and list our files we want to ignore in there. So these files will never be staged or committed. So let's create this .ignore file, and the way we will do that is do it through git bash touch.gitignore. Enter, and that's created the file on the right hand side. So if we go into the file, actually before we do anything, let's do a git status. So I can see both files. I can see my_notes.txt, but we can also see .ignore file in there as well now. And this is fine, as we want to track the .ignore file and let the team update and commit it when files need to be ignored. But the my_notes.txt is still showing, so let's update the .ignore file. And let's specify in here my_notes.txt, and let's save the file with a Ctrl S, and I'll cross this off. And now let's do a git status again. And we can see the my_notes.txt has now disappeared. It's not being tracked anymore because now we are ignoring the file, and this is what you want Git to do, to ignore files. So we can do a git add from here and a git status, and we can commit this one, and running a git status again will show us now there's nothing to commit, working tree clean. And of course if we remove the file from .gitignore, save the file, now we do a git status again, we can see the file is back. So we can see one file has been modified. We modified the .ignore file, and there's a new file which is untracked, my_notes.txt. And that's it for this video. That's how you unstage a file if you accidentally stage a file, and that's how you ignore files if you want Git to ignore files permanently. Git is a powerful tool, especially when you are collaborating with others. So this is when you are all working on the same project and need to keep it up to date when you are all updating the same content. With Git, with collaboration, each user has a copy of their own repository and they all have their own timeline of snapshots. Then with Git, we usually have a master repository that everyone pushes and pulls changes to and from, and so you want this master repository to be available from anywhere in the world, and this is why it's hosted on a cloud-based platform like GitHub, GitLab or Bitbucket. We will be using GitHub. We will be having a look at GitHub, and GitHub is a free and open source cloud-based service which is used for this very purpose. The first thing we will do is have a look at GitHub. What is GitHub? GitHub provides a platform for developers to host, manage and collaborate on code repositories. Git is a free and open source version control software that tracks changes to your source code. GitHub allows for real-time collaboration and is accessible from anywhere in the world, which enables teams to work together effectively. Using GitHub is optional if you only need to track your code locally, such as hosting repositories within your company's network over a VPN connection. Then it's not needed. You do not need anything in the cloud. Then it's not required. So GitHub is not mandatory for Git, but Git is mandatory for GitHub. You need Git to use GitHub. You do not need GitHub to use Git. And GitHub offers both free and paid plans, including free, pro and enterprise options. The free plan includes the basics such as unlimited public and private repositories with 500 megabytes package storage and 2000 automation minutes. The team plan offers advanced collaboration features with 2 gigabytes of storage, where enterprise plan includes all features of the free and team plans, along with enhanced security, compliance, flexibility deployment, and its 50 gig of storage. The platform supports both public and private repositories and was acquired by Microsoft in 2018, which increased Microsoft's focus and commitment to open source development. And additionally, GitHub includes features like continuous integration and deployment, as well as various collaboration tools. So that's a high-level overview of what GitHub is. Let's go ahead and create a GitHub account, and once we create a GitHub account, let's go ahead with creating a new repository and connecting this new repository in the cloud back to my local Git environment on my local machine. The very first step is to create an account on GitHub. For this, we'll go to github.com, and before I sign up, if I hover down, GitHub shows some of the latest and greatest features that comes with the service, so you can read more about those. Now I will click on the sign up button on the top right of the screen. Next, we specify our email address and create a password and enter a username for your GitHub account and click continue. After this, we verify the account and confirm the code they sent to your email address. And now you are done with this part and you can sign in. Now, upon signing in, you will get asked some questions. You can skip it. This part is to set up your environment with the correct level of services that you want to use. I think it's basically to upsell their other services or their other pricing models. They offer the three models: free, team and enterprise. Anyway, regardless, we are going to stick with the free one, but I'll go through this anyway. So it asks, how would you describe yourself? So I'm going to select student here just to see what options we get with student. It does, by the way, ask you to apply for the student services. To get the student services, we will see this in the next couple of screens. So let's go with student for now, but ultimately I'm going to go with the free option. How many team members will be working with you? Let's go with 2 to 5. And we can see here what specific features are you interested in using. I assume if you select any of these, it will try and upgrade you. It will try and ask you to upgrade to another pricing model. We will have a look at the pricing models as well. And here's an image of the pricing model. So you get these three pricing models: free, team and enterprise. Now if we click continue, next it shows us our free options, and because we did not select any of the other features in the previous window, it shows us only the free options and the get additional student benefits options. But we would have to apply for this. I guess we would have to show that we are a student. But I'm going to select the continue for free option. And that's it as far as initially setting up the account. And now it's landed us on the GitHub dashboard. So I'm logged into my GitHub environment and we are on the dashboard. So this is the GitHub dashboard. We can see it gives us some suggestions like explore other people's repositories or start a new repository. And we can specify the repository name and whether we want this repository to be public or private, and create a new repository right from here. And introduce yourself with a profile readme so everyone knows what my page is about. And then we've got some useful tools. By the way, that's start writing your code. Then we've got some useful tools of the trade. And we'll be having a look at this actually. Install GitHub Desktop, maybe in the next video. Then there's some AI-based code suggestions. Try GitHub Copilot for 30 days and so on. So this is the dashboard. Of course, at the bottom it's showing trending repositories as well. But on the left hand side, we've also got create your first project. So we can do this, or we can import a repository as well, but we will create a repository. So here is where we create our new repository. The first thing I'll do is give it a repository name. It could be a name of your project. I'm going to be very generic and call it my first project, but of course you can be very specific. So if it's a particular game you're building, a particular website, etc., you want to label it correctly, and then you want to give it a nice, precise and memorable description. And then you can choose whether you want this to be public or private. Again, public is anyone on the internet can see the repository, but you can choose who can commit to your repository. So although they can view it and pull from it, they cannot commit to it. But then you've got private as well, and private you can choose who can see and commit to this repository, but we will stick with public. So by creating a public repository, anyone on the internet can see that repository. However, you can control who can commit and make changes to that repository. But by creating a private repository, you have complete control over who can see and make changes to that repository. Then we have three more things. We've got the README file. With the README file, you can write down what your project is about and provide any instructions. So let's tick it anyway. Then with the .gitignore file, this will contain the names of the files you do not want to push to GitHub. So with Git, we track changes to files. And by using the .gitignore file, we can specify files in here we ask Git to ignore. And Git will no longer track changes to those files. These could be operating system dependent files, or just notes you don't want Git to track. Or they can be settings specific to your IDE, or files specific to a version. They can even be system generated log files that just take up too much space and you do not want to track them. Things like that. So I'm going to use Terraform soon, so I can ask Git to ignore all my Terraform related files. Of course, we can click on these to learn more about each of these as well. Next, we need to specify a license. A license tells others what they can and cannot do with your code. But there is quite a few options with licenses. If we have a look in here, So this is for the GitHub repository we're creating. It can be licensed under a variety of open source licenses, and a license tells others what they can and cannot do with your code. But we have quite a few choices, so we can go through them. And the top one is the Apache License 2.0. With this license, users must maintain original copyright notice and include any changes in the software, and it's suitable for projects that might involve patents or where you want to prevent patent trolls. It's common in enterprise environments, software frameworks, and large projects like Apache projects. Then the General Public License, GPL, is best for projects where you want to ensure that all derivative works remain open source. It's widely used in the GNU or Linux ecosystem and other projects where open source principles are paramount. Then we have the MIT license, which is a very common license. A lot of people use this, and this is because it's a very permissive license that allows for almost complete unrestricted access of use. So users can pretty much do anything with it, including selling copies of the software, as long as the original copyright and license notice are included in all copies of substantial portions of the software. So the license is ideal for projects where you want to maximize freedom for users, including commercial use, and often used in web development, libraries, and open source projects where the creator wants widespread adoption. Then there's the BSD2 and BSD3 licenses. These are similar to the MIT license. The BSD licenses are permissive and allow for almost unrestricted freedom. The 2 includes basic permissions, while the 3 clause adds a no endorsement clause. These are good for projects where you want a permissive license with a bit more control over endorsements. They are often used in academic and government projects. A lot of these licenses are very niche and specific to things. The Creative Commons licenses, and these are a range of licenses mainly used for creative work rather than software. And they are best for documentation, images, media, or other creative content within a project. So it's not recommended for software code. The Eclipse Public License, this is a copyleft license similar to the LGPL, but with different patent and compatibility provisions. And this license is suited for enterprise-grade projects, especially in the context of software that could potentially be integrated with other proprietary software. The AGPL Affero General Public License, this is a version of the GPL designed for software that is used over a network, and it's best used for web-based applications where you want to ensure that the code remains open even if it's used on a server-side context. The Mozilla Public License, this is ideal for projects where you want to enforce open source on a file-by-file basis, but allows for integration with proprietary systems, and it's commonly used in projects like Mozilla Firefox. Now at the very bottom we've got the unlicensed, and this places the work in the public domain, allowing anyone to do anything with the project without any restrictions or conditions. So it's useful when you want to completely relinquish all rights and allow other users to use your work without any conditions at all. It's not very common you would use this, but it is sometimes used for small scripts or snippets where the authors want to avoid any restrictions. So to choose the right license for maximum freedom of permissive use, you could use the MIT license, Apache 2.0, or the BSD license. These are ideal licenses for maximum freedom of use. For ensuring open source continuity, we would use GPL, LGPL, or AGPL. For a balanced approach, you could use MPL or EPL. For documentation or creative content, you should use the Creative Commons licenses. And for total public domain dedication, so it's completely unrestricted, you would use the unlicensed license. So for most people, they use the maximum freedom, which is MIT or the BSD license, I suppose. So if we hover to the top, so I'm going to go with MIT license here. And then at the bottom it says this will set main as the default branch. Change the default name in your settings. So we could do this, but I like to use the default branch name as main, as I have done in my Git environment as well. It's called main. My default branch is called main. And finally, we can create the repository. So this is it. This is my first repository, my first project. It's called my first project, and I have my 3 files in here, my .ignore file, my license, and my readme file. And so this is information about my license. It tells me the permissions, the limitations, and the conditions for the MIT license. Got my .ignore file here, and we can see it says local.terraform directories. So it's got all Terraform related things in here. TF state files, crash log files, exclude all TFVAR files, which are likely to contain sensitive data. So these are templates. You can use templates, but you don't have to use these. I chose the Terraform template, but we could start from scratch with nothing in here, and you just specify your files in here. And on the right hand side, you can download your files from here, or copy the raw file, or edit this file as well. If I click on edit, I can remove all this information if I like, start from scratch, and specify a file in here like myfile4.txt, and we can commit changes on the right hand side over here, commit directly to the main branch, add a description, ignore myfile4.txt, commit change. Let's hover over to the readme file, and I can edit this as well, put some description in here. This is my first project. I'll leave this as it is and cancel changes from here. So this is all done. And on the left here, we can see our files, but we can also see the branch we are in. So I'm in the main branch. I do not have any other branches created just yet. And we can click on the plus sign as well here. And name our file and put some content within our file. And then we can commit changes. Commit directly to main branch, commit changes. So now we can see myfile5.txt in there. If we click on the GitHub icon, we can go back to the dashboard. And at the bottom here, I can see my first project. If I go back in here, that's how we open up the project again from the dashboard. But on the right hand side here, I've got code. And in here, I can copy my URL. So I can copy it from here. But we've also got other methods as well. I can copy this, but we can do it via SSH or GitHub CLI as well. We can also download it as a zip file as well. And downloading it as a zip file is exactly the same as a git clone. So you can do that with no issues. So you don't have to use git clone command. This is a perfectly alternative way of doing it. Now to copy all my content, to clone all my content into my local repository on my local machine. So this is GitHub, my remote repository, and we are going to clone the content to my local repository on my local machine. So I have already copied the URL. I'll copy it again just to make sure. It's now copied to my clipboard. Again, I can do a download zip from here. I can also use other alternative protocols to do this with, maybe for security or compliance purposes. You can also open with GitHub Desktop. If you do this, it would open up the URL and everything for you on your GitHub Desktop on your local machine, and then you can just clone it with a click of a button. But we do not have GitHub Desktop installed yet. I will cover this off in another video, but for now we have cloned it, and now I can go to my local machine on my Git bash over here, and we can use the git clone command from here. Let's begin with doing a pwd to work out which directory we're in, and then do a dir. I've got a directory called my git project. So if we go into my git projects, we're in the directory I want to be in, and this is where we are going to create our new repository. So again, if I go to code and I copy the URL, we can see it's github.com followed by my name, followed by my project name, my first project. Now we can do a git clone from here and press enter, and that's done. So if I do a dir now, sorry, I have to go into my first project, but I'll just open up my folder instead. I've got my git projects in here. If I go into here, I've got my first project in here. Now if I double click my first project, we can see the files in here. So you can see the .ignore file, the license file. We can see the new file we created, my file 5, and the readme file as well. If I open up my file 5, I can see the same content in here as we had in the cloud. So that's how you clone a remote repository rather than starting from scratch. This is the alternative to using Git init. So rather than using Git init, starting a new project, you can clone an existing project for developers who want to work on existing projects. So that's how you use the git clone command to clone an existing repository in GitHub. Welcome back to another video. In this video, we are going to be having a look at GitHub Desktop. So GitHub Desktop is a software you can install on your computer and use it instead of having to learn the Git command line. It's a good way to start learning about Git when you're not familiar with the command line. So it's a nice, easy to use graphical user interface. Now just to step back for a couple of minutes so we understand the Git environment and the relationships between the different components, or services you can call them. First, we have Git version control software hosted on your local computer that is managing your Git repositories. And I have been managing my Git repositories through the Git Bash CLI. So I've been using the CLI in my previous videos. I've already created some repositories in my previous videos. Then we have our GitHub cloud-based service that hosts many repositories from anyone who wants to share their repositories, whether that's with their team, privately, or publicly with anyone across the world. By the way, I've also done a dedicated video on GitHub. Now, although GitHub has its own management GUI via a browser, it has its own dashboard and you can do things in there. As we've already seen in the previous video, we can also manage GitHub repositories via the Git Bash CLI as well. So my CLI, I manage my Git repositories. We can manage the repositories on GitHub as well to some extent. So we can push, pull and clone repositories amongst other things from GitHub using the Git Bash CLI. However, instead of using the CLI in this video, we're going to be installing and using GitHub Desktop. And with Git Desktop, we are not only going to be creating new repositories, but we will also take a look at adding already existing repositories that I had created in my previous video when I created them using the CLI. So we'll take a look at how GitHub Desktop interacts with new and existing repositories. And we will take a look at repositories hosted on the cloud-based hosting service GitHub and how GitHub Desktop manages those repositories as well. So let's get started. The first thing we want to do is install the application. I can either install GitHub Desktop from my dashboard. I'm signed into my GitHub account, or we can look for it on Google. And the options are we can download for Windows 64-bit or later, and there is also a macOS app for it as well, so we can download the macOS app from here. But I'm going to download it for Windows 64-bit, and now it's downloaded, we can open up the file. Once we have the app open, we can sign into our GitHub account from here, or if you don't have an account, we can create one from here. Create your free account. But I have one, so let's sign in. So over here it's asking us to select a browser to open up the sign-in page with. So I'm going to do that now and click on continue. And it's telling me over here, GitHub Desktop wants to access my account. And now I need to authorize my GitHub Desktop to access my GitHub account. Now it's asking me to configure Git, and it's auto-populated my name and email address. This is used to identify the commits you create. Anyone will be able to see this information if you publish commits. So any commit I make to my repositories, the name and email address is associated to it. You can customize this, however, per repository. So this is global, but you can customize it for each individual repository. Of course, if you wasn't happy with this information, you can configure it manually from here. Now it's installed GitHub Desktop, and what we can see is we can create a tutorial repository, and the tutorial repository will introduce the basics of working with Git and GitHub, including installing a text editor, making a commit, creating a branch, and pushing all of this to GitHub and opening a pull request. So it's ideal for learning how to use the GitHub Desktop. And we can see when I clicked on it, it says this will create a repository on your local machine and push it to your account. This repository will be visible to you and not visible publicly. So we've got that option. Then we've got the option to clone a repository from the internet. So if you know a repository you want to clone, you can select this option. And it gives you the option to use github.com, so you can clone from github.com, you can clone from GitHub Enterprise, or you can use a specific URL. So those are the options available as well. And then we have got create a new repository on your local hard drive. And so we can create a new repository. In fact, we can do this now. You want to give it a precise description what your repository is about. And we can specify the local path. I've already got an area where I'm storing my future repositories. So I just need to look for it and create a folder to create my new repository in there. There it is. This one here. My Git project. So I want to create a new repository. And if we look at this, if you have watched my GitHub video, here is where we create the README file. This is for more details about your project and any instructions you would like to associate with it. Then we have the .gitignore file where we specify any files we want Git to ignore. So files part of the project we want Git to ignore. We can specify in here. And then the license. So I'm going to specify the MIT license. because it's a very permissive license that allows for nearly unrestricted freedom. It's the most popular license, everyone uses it, and users can use, copy, modify, merge, publish, distribute, sublicense and sell copies of the software using this license. And then we can create the repository. So now we have created our new repository, and near the top we can see our repository. So the current repository we're in, and we can see our repository name. This is the current repository we are in, and we can see the current branch we are in, which is main. If we had more branches, we would see them in here. And we can also publish the repository to GitHub. So that would clone the repository and push it into the cloud into my GitHub account. And on the left we have two tabs. One's the Changes tab and the other one is the History tab. In the Changes tab, this is where we see changes about our repository, what has changed, etc. And below this is the Commit box where we commit our changes. So we specify a summary. We can choose to specify a description as well, and then we can commit to the main branch. And the History tab will show us all of our history. Currently it only shows our initial commit where we created our new repository. We can see 3 changed files here, plus icon indicates a new file. We will also see a yellow icon with a dot inside it, and that indicates changes to an existing file. And we will have a look at that shortly. This is actually the .git attributes file, which is a configuration file in the Git repository. It's used for defining paths and files in a Git repository. It's basically there to define how Git should treat certain files. For example, line endings, merge strategies, and file encoding. If we go back to the Changes tab, in the middle we can see it's telling us this repository is currently only available on your local machine. And by publishing it on GitHub, you can share it and collaborate with others. So it's telling us to publish our repository, and we can view our files. So we can have a look at them in Explorer. So it's opened it up and we can see those 3 files. Git attributes file, the license file, and the readme file. The ones we just seen in the History tab over here. So this is my new repository, and we can see where the physical files are kept within this folder here. Another repository for GitHub Desktop. We could create more files in here. Let's create a text file and just put something basic in it, like test my file. Let's close the file. And now if we go back to Git, it has detected my new file. So it's very instant. And now it's asking me to commit to main. Before this was grayed out, but now it's in blue. Let's make a change to the file as well. Let's save that. Let's go back to Git. And we can see instantly Git has detected another change. So we can now commit the change. Of course, you want to make sure you specify some clear, concise messages, a commit message and a description, and then commit to main. So we have committed to main, and if we go to the History tab, we can see our new commit. So this was my commit message, and it shows me my name, and the commit was just done now, where the initial commit was done 17 minutes ago. Now if we go back to changes, and actually if we go to my GitHub account, I can see my first project in here. This is my repository I created with my GitHub account. So I created this previously in the GitHub video on this page using the new repository button from here, or you can do it from here as well. But the point is we only have my one repository. If I go back to my GitHub desktop, we publish our local repository. So we'll keep the same name and we'll keep the same description, and we will keep this code as private, and we can see it's doing something in the background. So now if we go back to my cloud-based service GitHub and have a look at my dashboard, I now see my repository. I can go into this repository and I can see my files in here. So I can see my test file I created, and I can double click it and see my 2 changes in here. So that's how you create a new repository, and that's how you publish it to GitHub. Now going back to GitHub Desktop, at the top we've got some more options. So we've got file, and in file we've got new repository, so we can create a new repository from here. But we can also add a local repository. So if we've already created a repository, for example, we used Git Bash, the Git Bash CLI, to create a repository, as I have done in previous videos, and then we later introduced GitHub Desktop. This is the way we bring that local repository into GitHub Desktop. And we can do this now. So if I click it, we have add local repository. So if I find my very first local repository I created, I think it was this one here, my Git, select folder, add repository, and there we go. I have just added my Git repository into GitHub Desktop. and we can see the current branch is main, but I can also see I have another branch in here. So we created another branch in one of my previous videos called my_branch2. So we can switch to the branch if we wanted to, and we can also publish my repository to GitHub as well. Another thing we can do in here, if we go to file, as well as adding these repositories, we've got options. So we've got quite a few options in here. So we've got accounts. This is for my accounts, integrations, and I can add Visual Studio from here as well, or any other text editor. And we can specify the command prompt, PowerShell, Git Bash, Windows Terminal. So in here, I can integrate Visual Studio Code or another external editor. I'll just have to specify the path to it as well. And then we can specify our shell. My preferred choice is Git Bash. Then we've got Git. Now this is where we can specify our name and email address, which is associated with every commit we do. So these are global settings. This is associated with every commit, but we can change these for a specific repository. For example, so someone else is managing another repository and making commits. We can do that from the repository section in here. And then there's appearance. You can change the theme, notifications. You can enable notifications. We've got prompts, so confirmation dialogues, prompts, warnings about branches and commit length. So this is a good one. If I have changes and I switch branches, so what happens with the changes? Ask me where I want the changes to go. Always bring my changes to my new branch. Always stash and leave my changes on the current branch. So we saw this a few minutes ago when I cancelled, but you can change the options in here and some advanced settings and accessibility settings. Let's click on save to save changes. We've also got edit, which has the usual cut, copy and paste and find. Then we've got view, view changes, history, repository list. Let's have a look at that one. Repository list, it will show us our repository list. So another repository for GitHub Desktop Demo, and then my Git. And it shows us in blue there are uncommitted changes in this repository, and we can add repositories from here as well. Branch list, so we can see our list of branches, and we have some other options like zoom in and out, etc. And this is all about the repository, so we can push the repository. And then we've got other repository specific actions like pull, fetch, remove, open in Git Bash, show the repository in Explorer, open in external editor. So this is where we went into file options. We could integrate an external editor. And we also have repository settings. So here's the ignored files, the .git ignore file. Here's the git config settings. And this is where I can use a local git config. So I can configure someone else's name and email address associated to this specific repository. So if they were pushing and committing changes to this repository, I could use their details in here. I'm not sure if we have clone a repository. So we can clone a repository from GitHub. GitHub.com, and I've got my first project in there, so let's click on this one and then click clone, and now it has cloned my first project. If we have a look at the history, we can see the history information. So I created all of this in GitHub. It's pulled it all down, and it's pulled down the history information as well. So you can see we created that repository 15 days ago, and then I updated the .git ignore file, and I also created myfile5.txt. We've also got the fetch origin option. So if there are changes made to the remote repository, you can pull them by clicking the fetch origin button, and if new changes are detected, we click pull origin to merge them into your local copy. So we can click this and it will have a look for us to see if there's anything there. Or we can go to GitHub. I'll go to my first project. I can make a change to my file 5 in here. New change, commit changes. Commit directly to the main branch. And now if I go back to GitHub Desktop, I can do another fetch origin. So we can now see it's done that 1 minute ago. Update myfile5.txt. And we can see the specific change inside the file, new change. And the final two tabs is branch and help. With help, we can get some help. We can have a look at some logs in Explorer. We can have a look at our keyboard shortcuts, but we can also do many things with branches inside here. So branches allow you to work on different features or bug fixes separately from the main code base. So you would create a new branch if you was working on a feature or a bug fix. And the way we would create one is by selecting new branch. and then we can give our branch a name. Let's call it feature1 underscore branch, and then we create the branch. So now if I go to the branch option here, I can see both branches, main and feature1 branch. And the way to switch branches is just by selecting them. So I've selected the main branch, it's going to switch me back into the main branch. If I go back to feature1 branch, if I go to repository, show in Explorer, go to my file 5, let's make a change. Let's call it feature1 branch, change to add a new feature, Control S to save it. And then go back to my GitHub Desktop. We can see it's detected the change. Now I want to merge this change back into the main branch. So how I would do that is I would go back into the main branch, and I could either leave it as it is, leave my change on feature1 branch, or I could merge it back into my main branch, bring my changes to main, and then switch branch. And then we can commit our changes. Now it says you have one local commit waiting to be pushed to GitHub, push origin, and it says it over here as well, push origin. So of course we can do that as well. And that's it for this video. That's a high level overview of GitHub Desktop. So that's how we create new repositories in GitHub Desktop, and that's how we add already created existing repositories into GitHub Desktop. And we also had a look at how to push and pull changes to GitHub in the cloud. And finally, we had a look at branches, how we create new branches, make changes, and then merge them back into the main branch. Welcome back to another video. In this video, I wanted to have a look at how we sync changes between GitHub and our local repository. So that's repositories stored on the cloud-based hosting service on GitHub and my local repository on my local machine. We can do this using a number of commands and flags, but today I want to focus on the most common ones, which is git push, git pull, and git fetch. The first command we will have a look at is git push. So we'll push our changes and sync our changes with a remote repository. This could be the master repository. In our case, we are hosting on GitHub, or you can use any of these commands, including the git push command, to sync changes with any of your team member repositories. So it doesn't just have to be with the master repository on GitHub, it could be with any of your team members as well. And you do this simply by pushing and pulling changes with their repositories. So we would use git push to push commits made on your local branch to a remote repository. And git push is the actual command, and then the origin, which is the alias, or you can use the URL itself, but this is the alias to the URL. So you don't have to specify a long URL, you can just use the alias origin. And then you specify the branch name. In this case, I have called it main. So git push origin main. Let's have a look at an example of doing a git push. So we are back on my git bash. I can see I'm in my repository, my first project. We are on the main branch. And physically I can see my files in my folder, in my directory. So I've got my license file, my file 5, and my readme file. If I go back to git bash, I can do a dir to ensure I've got the files in there. And also on the right hand side, I'm in my GitHub and I'm in my first project. We can see the files in here as well, license file, my file 5.txt, and my readme file. So to demonstrate the git push, let's create a new file called myfile6.txt. Next we will do a git add and a git commit to commit the file into our local repository. And we can also physically see the file has been created over here. So now what we want to do is use the git push command. So it's git push and then origin, which is an alias to our URL, followed by the branch name, and in this case it's main. So it looks like it's done that. So we can see my first project, and we can see we are in the main branch on GitHub. I do not see my file 6.txt here. Let's go back into the project to give it a refresh, and now we see my file 6.txt. So that's how the git push command works. So it's the same thing if you edited a file as well. So if we changed content within a file, it's effectively the same thing. The next command we will have a look at is the git pull command. So with git pull, it's the opposite of git push. We can pull changes from the remote repository into our local repository. However, if we look at git pull under the hood, it's actually a combination of two commands, which is git fetch and git merge. So to understand this, you need to know the different directories or structure of the Git environment. And you can see in the box on the right hand side, we've got the local repository where all our commits, our snapshots are stored for our branches. Then there is the working directory, also known as the working tree, where we actively work on our files that are being tracked by Git. And with git pull, it fetches the change from our remote repository, and it also does a git merge, which merges the change into our working tree. Just to bear in mind, however, when using the git pull command, the user must not be editing any tracked files that conflict with those on the remote server, as if Git detects any conflicting files in the local workspace, it will stop the process of updating the workspace and only update the local repository. So in effect, it will only do a git fetch. And moving on to git fetch, so git fetch will download a copy of those commits. Git fetch allows you to keep working in your local files without needing to merge your changes with the updates from the remote repository. So with the git fetch process, it downloads it, but it does not merge it. Let's have a look at an example of both git pull and git fetch commands. We're back on the Git environment, and the first thing I'll do is create a new file on GitHub. So if I create a file on GitHub called myfile7.txt, let's put a comment in there, test git pull, and we will commit changes. Let's commit it to the main branch, and I'll click OK about discarding anything else. And we can see the new file in here, and the message is create myfile7.txt. So this file has been created in GitHub, but I want to pull it down into my local Git environment, and we can currently see the content, and myfile7 is not in here. So we're going to do a git pull from here, git pull origin, and now we can see down here myfile7 has appeared. So simple as that, using a git pull has pulled down myfile7. Now, as we have seen on PowerPoint, the git pull downloads a copy into your local repository, but it also merges the changes into the working directory, also known as the working tree. But the git fetch only does the former part of that, which is the download. And let's have a look at an example. So what we can do now is add another file called myfile8.txt, and let's put a comment in here to demonstrate how git fetch and git merge works. If we commit changes over here, and the commit message is fine, create myfile8.txt, let's commit changes to the main branch. So we now have a new file, myfile8.txt, create myfile8.txt. Let's go back to my local Git environment on my local machine, and let's use the command git fetch. So we can see it's successfully done that. It's not coming up with any errors, any issues. It's copied any changes from my first project on GitHub into my main branch, but unlike the git pull, the file has not appeared, so we do not see the file. We can do a dir as well to confirm it. However, if we use the command git merge to merge the changes into the working directory, we should see the file. So let's have a look at running this command. Now instantly on the right hand side we can see myfile8 has now appeared. One thing I forgot to show is how we verify the status after we do a git fetch. So if I create a new file here, let's call this new file myfile9.txt, and let's commit changes. So we have created myfile9.txt. Let's go back to git bash and do a git fetch. And it's done that. So the way we verify what we have just downloaded, because that's the whole point of git fetch, is to safely verify what we have downloaded before merging it with our other work, rather than blindly downloading and merging it with a git pull. So git fetch and then git merge is a safer method, because it gives you time to review what you are about to merge. So first, let's do a git status, and we can see it says your branch is behind origin main by 3 commits. We can also do a git log origin/main, and we can have a look at the logs. So we can see at the top I've got 3 create myfile9.txt's, because I did a couple offline to test, because I did one offline over here to test, and then I deleted it, and now I just recreated it on the video. So that's why it's saying we are 3 commits behind. So 2 of the commits I did just before I started to record this video. And also if we go back to the bottom, we can do a queue for quit here, and then we can do a git diff as well to verify what's different. Git diff origin main, because my branch is called main and it's showing us what's different. So we can see here myfile9.txt. So we can see here myfile9 is the main change. So if I'm happy with myfile9.txt and I want to merge it, I can now proceed and go ahead with a git merge. And of course I can do a git status just to make sure we are all up to date now. So we can see it says your branch is up to date with origin main, nothing to commit, working tree clean. And finally, just to have a look at origin again, so the way we verify what our origin is set to, we can do this with a git remote -v. So in our case, for both the fetch and the push, we have the same URL, which is my first project hosted on my GitHub account. And that's it, that's the differences between git push, git pull, git fetch and git merge. And you would do a git pull if you are completely satisfied, you're happy with downloading the changes and merging them. But if you wanted to review the changes, you would do a git fetch first, you would then review the changes before you do a git merge. Welcome back to another video. In this video, we're going to have a look at branching and merging changes using Git. We have a few options with the types of merges we can do on Git branches, but the two main ones we will be having a look at is the fast forward merge and the three-way merge. Let's begin with the simplest of merges, which is the fast forward merge. So we have been working on the main branch. We have our commits. We can see 3 commits in front of us. And so let's say we are asked to work on a bug. We have a bug to work on. So we need to fix a bug. So what do we do for this? We create a dedicated branch to work on the bug. Let's call this branch bug fix. So we create this dedicated branch. This way we don't mess around on our main production code on our main branch. So we now have our isolated environment, our isolated branch, which is our bug fix branch. Now that we have made a few commits on the bug fix branch and finished working on the bug, we want to merge our changes back to the main branch. So we want this single timeline again. But if you notice, since we worked on the bug fix branch and made a few commits, we can see 3 commits, nothing has changed on the main branch. The same commits still exist on the main branch, and the latest commit is still the same commit, which we used as a base when we created the bug fix branch. So as there has been no other changes on the main branch, since we made these changes on the bug fix branch, we may as well add these latest commits we did for our bug fix branch to the end of our main branch and consolidate it to a single timeline that way. And for this, a new commit is not even required. We have all the latest commits consolidated into a single timeline now. And what else the fast forward merge does, so it's consolidated them into a single timeline. Git just moves the tip pointer to the latest commit, which becomes the head, and any new commits will follow on from the last commit. And this is known as a fast forward merge. So we can see there's been no new commit created to merge these two branches back together again. It just moved the tip of the main branch forward to the end of the bug fix branch and consolidated it back into a single timeline. The next type of merge we will have a look at is a three-way merge. So looking at the three-way merge, we are working on our main production code, which is our main branch, and we have some commits on them, so we have 3 commits. Then we are asked to work on a new dedicated feature. So we create a dedicated environment for this, a dedicated branch called the new feature branch. That way we can work on our new feature without messing around with our main production code. Now we have created our new feature branch and we have been working on our new feature branch and we have 4 commits. And let's say our new feature was ready, so we wanted to merge it back into the main production code. However, since we have been creating these commits for our new feature, there has also been some commits made to our main production code as well. So there has been some changes to our main production code. So since the common base, we have changes. So now we have changes on the main production code and we have changes on the new feature branch as well. So we need to combine these changes and consolidate it all back together again. We need to merge all this back together again. And this is where we do a three-way merge. So the three-way merge being the latest commit on the main branch, the latest commit on the new feature branch, which results in a new commit based on all of the changes that have occurred. And that's why it's known as the three-way merge. And this becomes the new head as well. So this is it. This is the three-way merge. And as a result, it created a new commit, which consolidated all of the changes together. And of course, any new commits will follow on from the latest commit. And all the latest changes are back in the main branch because that's what we did for the three-way merge. And the way we did this, and by the way, we are going to have a look at this next, is we went into the main branch and then we specified to merge the new feature changes with the main branch changes. So let's have a look at these changes next. And we are also going to have a look at how to resolve conflicts. So that is, let's say some code has changed on the same line on 2 different branches of the same document. So we will have a look at that as well. So I am back on my Git environment. The first thing I can do is a Git status. So there is nothing to commit working tree clean. I can do a Git log. Just to have a look at some logs. It looks like I created a new text file. And I can also do a Git branch. And we can see we're on the main branch here. And on the right hand side, I've got my physical files. So if I do a dir from here, I can verify these are the files I have in my physical directory. So I'm going to get rid of these files just so everything is a bit easier to see. And I will copy my file 5 and I will call it main production code. And here's my file 5. Type something in here. Main production code for my main branch. Let's save the file, let's close the file, and then let's do a git add period, and let's commit the changes. So that's all done, and it gives us a summary of what we have deleted and what we have created, including changes within the files as well. And we can do a git log --1 line just to verify the logs. So we can see here that's my latest change, my latest commit. Now the way we create a new branch, and the way we do that is so git switch -c for create, let's call it new feature. And it does say switch to a new branch, new feature, and we can see it here, new feature. So we are on the new feature branch. Maybe I can do a git branch from here just to verify that. And we can see this by the star. So it indicates what branch we are on, but we can see the two branches as well, new feature and main. So now our head is pointing to new feature branch. And now what I can do is maybe create a new file, call it new feature. And if we edit my file 5, and now if we make changes to my file 5, let's specify in here code for my new feature. So this is the main file we are focusing on, the changes in here. I'm not sure why I've done these two. I've just done them so you can see how new files are added and removed as well. But the main focal point is my file 5. And we can do the usual git add period, git commit -m, changes to new feature branch. And of course we can do git status or a git log just to see our latest commit. Now to migrate the changes back into the main branch, we need to be in the main branch. So you need to be in the branch which you want to merge your changes into. So if we want the changes from the new feature branch to be merged into the main branch, we need to be in the main branch. So for this we switch back into the main branch, and it tells us there switched to main branch main. Actually, before we do a merge, because this will be a fast forward merge, we've not made any changes to the main branch since we updated the new feature branch. So this will be a fast forward merge. It just works and it moves the pointer to the end of the new feature commit. So we want to make some more commits to the main branch, because then we have changes made to the main branch whilst changes were made to the new feature branch. So both branches had changes made. And by the way, because we are back on the main branch, we can see the new feature text file has gone. I created a new feature code file, but that's disappeared. So if I go to my file 5, I can also see my code in here has disappeared because I put something in here as well about the new feature. And over here I can put some more production code to main branch. And I'll save and close the file. Again, you can do a git branch to verify which branch you're in. And we are back on main. It says it here anyway on the right hand side. And now to merge the changes in new feature branch with the main branch, we just do a git merge new feature. And of course, I forgot to do a git commit, git add and a git commit. So it's reminding me, git add period, git commit -m. By the way, if you scroll up and down, it remembers the commands you have specified. I've gone 3 up and press enter again. And it opens up our notepad with the default merge message. That's fine for me. I will cross this off and it continues with the merge. So it even tells you here, hint, waiting for your editor to close the file. And then it gives us a summary of the merge made by the ORT strategy. And then it tells us what merges have been completed. So if I have a look now, I can see my main production code and I can see my new feature code. I can see both of them. So I guess it was a good thing to add each of these files in each of the branches. So we can see how it's all merged together now. And if we open up my file 5, we can see the 2 lines of code for the main branch, but we can also see it's merged the code for my new feature branch as well. So all the code has been merged. There are no conflicts because these 2 lines, or 3 lines, do not conflict with this line here. But if we did cross this off and we did create a conflict, first let's have a look at which branch we're in. And we can do a git log -1 line, just have a look at our commits again. So let's keep the new feature branch, but let's create a new conflict in my file 5.txt. So let's do this line is for my production code, and let's save that. cross it off, git add and git commit. Now let's go into git new feature with the git switch command. And let's change my file 5 in here. And I'm going to type, this line is reserved for my new feature. So we can see there's going to be a conflict because in the main branch I specified something about my production code, but in the new feature branch I've reserved it for my new feature. So you can imagine this is code for my new feature, and in the main branch it's my main production code. So there's a conflict. I've saved the file. Let's commit the changes. Now let's do a git merge. We will merge the changes of new feature into the changes of the main branch, and we can see here it says conflict content merge conflict in my file 5.txt. And of course here it says automatic merge failed, fix conflicts and then commit the result. So it's asking me to fix it. This is a manual fix. You sometimes have to manually fix the change. So whose changes do you want? Whose changes do you want to keep? So if we go back into my file 5, I have never tested this on Notepad myself, but we can see where the head is pointing at, and it says this line is for my production code. And then we can see the code from my new feature branch. This line is reserved for my new feature. So what we can do is if I delete this, so I've deleted it all, let's save the file, cross it off. Or actually, let's just say we do not want to remove the line, we just want to make changes. So code for my new feature, and this line is for my production code. So let's have them both in there. And then this line is reserved for my new feature. Let's remove all the markers. So let's pretend this is what my code looks like. So I've got all my code in there now. I've got my new feature code in there, and I've got my production code in there, and I've got my new feature code in there again. Let's pretend this is what my actual code will look like. So I have manually fixed the issues. This is how I want my code to look like once it's all been merged. So I can just save the file, and so I can cross this off now. And what I can do instead is a git add period. I can do a git status from here just to have a look at where we are. And we can see it says all conflicts fixed, but you are still merging. And it shows us the file, of course, my file 5.txt has been modified. So I'll do a git commit, which will complete the merge. Now, if we do a git status again, we can see there's nothing to commit. Working tree clean, git branch. I'm in my main branch. My new feature branch still exists, but I can delete that if I wanted to. But if I go into my file 5.txt, we can see we have our code the way we wanted it. And I can do a git log as well, just to verify the changes. So here's the latest commit we have done. So now we have looked at the fast forward merge and the three-way merge, the true merge. So just to reflect, a fast forward merge happens when the branch being merged can be simply moved forward because there are no additional commits on the target branch. And this happens if the target branch has not diverged from the current branch. So there was no more commits on the main branch. And you would do this if you wanted to incorporate changes from one branch without creating a merge commit. Now with the three-way merge, this occurs when the branches have diverged. So you've got the main branch and the new feature branch, and they both had changes to them. And you would use this when both branches have diverged and you want to preserve the history of both. Now there's a squash merge. A squash merge takes all the changes from a branch and it squashes them into a single commit and merges it into a target branch. So the individual commits from the source branch are not retained in the target branch. And you would use this when you want a cleaner history by combining all the changes into a single commit. Now there's another one, it's called rebase and merge. Instead of a traditional merge, this approach rewrites the commit history to the source branch to appear as though changes were made directly on top of the target branch. So with this, it avoids a merge commit and creates a linear history, but you have to be careful with this. This could be drastic as well, it could cause issues. And you would use this when you want a clean linear commit history and you are comfortable with rewriting the history. Then there's the no fast forward merge, the no fast forward option. With this, Git creates a merge commit even if a fast forward merge is possible. Because with the fast forward merge, don't forget you don't actually create a commit. It just moves the tip header. And this is useful for preserving the context of a feature branch in the history. And you would use this one if you wanted to explicitly record the existence of a feature branch, even if fast forward merge was possible. Then there is a conflict merge, when two branches have changes that overlap, just like we have just seen in this video. And with this, Git will pause the merge and prompt the user to manually resolve the conflict, just like it asked us to resolve the conflict. And of course, you'd use this when the branches being merged have conflicting changes that need to be resolved manually. And that's it for this video. That's a high-level overview of branching and merging changes between branches using Git. In this video, we're going to have a look at another method to view our files in the staging area and the working directory using a command called Git LS-Files. The command combines all of the files in the index and the working directory and shows the different combinations of the two. And you can use arguments to filter on different aspects. Let's start off by adding a couple of files, my untracked file and my tracked file. And for completeness, my staged file. Although we have other files that have been staged in the past, we will create it anyway. Let's do a git status to verify the status with these 3 new files created. Next, I'm going to add my tracked file to the staging area and then do a git commit. And actually, I want to add my staged file as well. So if I do a git status from here, so I can see I've got my staged file in the staging area ready to be committed. And then I have my untracked file, because new files by default, they are untracked until you add them. But my tracked file is missing. Let me make a change here. So I've made a change to my tracked file. If I do a git status again, now we can see 3 things going on. One is my staged file, and the other one is my tracked file in red because it needs to be added to the staging area. And the third one is a new untracked file that again needs to be added. So we have one untracked file, one tracked file, and we have one file sitting in the staging area. So now this brings us on to the Git LS-Files command. So if we run Git LS-Files with no arguments, I'm missing an S at the end, so let me put that in. And this pretty much shows us all of our content. It shows all of the tracked files, whether they are staged or not. And it shows us our staged files. So we can see them here. So we've got our staged files we staged in the past. Our currently staged file. We have also got my tracked file in here as well. And then this one which has been also staged in the past. But the two we just added, my staged file which is in the staging area and my tracked file. They're both here. So the point on this one is to take away is Git LS-Files. It shows all tracked files whether they are staged or not, as long as they are being tracked. And also what we can do instead is Git LS-Files, and this time we will use an argument, but let's run the help command. And we can see here we can run the -s for stage, show staged content, object name in the output. So if we go back to the command, Git LS-Files -s, and that's what it means by show object name in the output. We can see it's got its object identifier here. And these again are files that have been staged or currently staged. So again, we can see my staged file.txt. And you may be wondering why my tracked file.txt is in here, because at the moment it's sitting in the working directory yet to be staged. Well, we staged this file in the past. So that's why it is showing as part of the staged content. But as we can see, we've got many flags here. So we can see -m for modified files in the output, cached files, show cached files in the output, deleted files in the output. This is a good one, -o for others, show other files in the output. So let's have a look at -o. If we do -o here, the reason I want to have a look at -o is because it shows other files, meaning not tracked files. So hopefully we should see our untracked file, and there we go, we see our untracked file in here. If we had files we was ignoring, which is in another video, we could even list those files with the -i command. So these are files we want to ignore from tracking, like log files and system files, etc. So that's it. That's a high-level overview and another way of looking for your files using the Git LS-Files command in the different areas of Git. In this video, we will have a look at the git clean command, which is a command to remove untracked files from the working directory. Now that we have an untracked file in our working directory, which we can see with the git status command. So we have this my untracked file.txt that I've created, but it's not been staged. It's sitting in the working directory. And let's say I created it by accident. So we now want to delete the file. We do not need it. And for this, we can use a git clean command. But if we have a look at the help options with the git clean command, so there's some arguments we can add to the git clean command, but actually let's try and remove the file first. And we can see straight away we get a fatal warning. Clean.require false is true and -f not given, refusing to clean. So it's basically saying use -f if you want to remove this file. So it's a warning about completely deleting the file, as it will be lost forever, as the untracked Git file cannot be recovered if we delete it. So you have to be sure you do not need the file when using this command. But also for safe side, if we have a look at -n, this option here, we can do a dry run of it before actually removing the file. So if we do a -n instead, at least this will tell us we would be removing the my untracked file.txt. So it confirms the file we are removing. So I'm happy with that. Now we can do a git -clean -f. And before we continue, you can also do a D as well if you had directories. So if we were removing whole directories. So if you had created some directories and we were removing them as well, that were untracked of course. So git clean -f and let's press enter. And we can see it's gone. So it's gone from our folder on the right hand side here. And if we do a git status, we can see it's no longer there, no longer listed as an untracked file. So it's been removed. So you just have to use git clean cautiously as the file is gone forever. And this is why developers tend to use git stash instead. Git stash will record the current state of the working directory and the staging area, the index, but revert you back to a clean working directory. In this video, we'll have a look at the git remove command, the Git RM command, versus the standard Linux remove command to remove a file from our Git repository. So to remove a file, since we're using git bash, we can use the remove command, which is RM. So let's say, for example, let's do a git status first to make sure we are up to date. Now let's say, for example, we wanted to remove my file.txt. So let's do an RM for remove my file.txt and remove the file. And now we can see on the right hand side the file is no longer present. It's been removed. And now what we can do here is a git status. However, when we use this command using a git status, it shows the change in red, asking us to add the change to the staging index. So next we would have to add it to the staging index. So I can do that by git add myfile.txt. So now it's been staged to be deleted. I can finally commit the change. So if we had noticed, we had to add it to the staging index and then commit the change. Instead, what we can do is use the Git alternative command for this, which is Git RM, Git remove. So let's remove my file too. Let's do a git status first to make sure everything is clean. So let's say, for example, we wanted to remove my file 2 this time. So we'll do a Git RM instead, and then myfile2.txt. And then if we notice on the right hand side, myfile2.txt has disappeared. It's been removed. And if we do a git status from here, we can see it's jumped straight to green. So it's already been staged. Now we can see for convenience, it's a better command to use because it already stages the file for us. So we just need to do a git commit from here. And that's it. So using the Git RM command, it removes the additional step of having to stage the file. So that's the difference between using the standard Linux remove command versus the Git remove command. In this video, we will have a look at how to rename or move a file in Git. So to start with, let's create a file. Let's call it my file. And then on the left hand side, let's do a git status. And we can see the file in red. It needs to be staged. So let's do a git add period to stage the file, and then a git commit to commit the file. So let's say, for example, we wanted to rename my file to myfile2. And the way we can do that is use the Linux command, the MV command for move. And we can do move myfile.txt to myfile2.txt. And what will happen here is two things. Let's do a git status first to see where we are. And we can see the two things on the screen. So first it shows us the changes to be staged. So the staged change is to delete myfile.txt. And then we have a new untracked file, myfile2.txt, that needs to be staged. Of course, with new files, Git does not automatically track them. So this is why it's in red. We have to tell Git to track them using the git add command. So let's do a git add period to stage both of the changes. Or by the way, you can do a git add myfile.txt and myfile2.txt. So this is another way of doing it as well. Now if we do a git status, now if you notice, Git has noticed that actually myfile.txt has been renamed to myfile2.txt. So Git has automatically noticed this for us and renamed it accordingly. So it has recognized that this is what we was intending to do. We was intending to rename myfile.txt to myfile2.txt. So with this being mentioned, we had to do multiple things. We renamed the file using the MV command, and then we deleted and added a file to the staging area, and then we staged the deletion and the addition of a file. So it was two different things. Let's finish off this commit for now and do a git status to make sure everything is clean and up to date. So now the alternative git command for this is git move. Just like the git RM command for removing files, we have the git MV command as well. So let's rename myfile2 to myfile3, but this time we will use the git MV command rather than the standard Linux move command. Git MV myfile2.txt, myfile3.txt. And let's press enter. So of course I've missed the capital for F. Let's do that again. Now if we run a git status, we can see it's already added the required changes to the working directory and to the staging area with a single command. So it's no longer in red. We do not see a deletion to delete myfile2.txt and to add myfile3.txt to the staging area. It does not need to be done. It's already staged the change. It's already picked up that it needs to be renamed and it staged it for us. So all we need to do from here is a git commit -m and a commit message. So again, using the git MV command, just like the git RM command, removes that extra additional step for us. In this video, we'll have a look at the Git Restore command. To restore file, we have removed from our repository in Git. Now over here, I have myfile3. So let's remove this file and let's commit the change. So now we have removed myfile3. It no longer exists, and we can see that on the right hand side as well. Now there's multiple ways to restore that file, but actually there's a command called Git Restore. But of course you can restore the previous commits if you wanted to. But if you wanted to just restore that particular file, you do not want to restore a whole commit. It might have many changes in the commit and you do not want to restore all of those changes. You just want to restore that particular file. We can use the Git Restore command. So it's Git Restore, and we can have a look at the options in here. If I spell it correctly, Git Restore -h, and we can see a number of options in here. You can restore it from another branch. So it can restore from another environment, such as another branch, if we wanted to do that. But the way it works by default, it restores from the staging area. And then if it's not there, restore it from the last commit. Or we can restore the file from a particular commit. So the command we can see here is --source equals. And then we can specify a branch, or we can specify a commit as well, followed by the file name. So what we can do here is if we do a git log --one line. So we can see on this particular commit here, we renamed my file to myfile2. So let's use this one. So let's do a git restore --source equals 8b470a9. And then the name of the file, so myfile2.txt, and press enter. And we can see on the right hand side, we can see myfile2 has now appeared. So we've got it back. So that's how we restore a file. So next we will have a look at how we would review changes in the working directory in Git. To see changes in the working directory that have not been staged, we can run the Git Diff command with no arguments. So we can do this Git Diff. And we can see we have a change in the working directory myfile2.txt. So if we press enter, by the way, there's some tools you can use. You can use tools to view this, which is much easier to view this kind of information, especially when it's a large file and there's many changes. You want to use a visual tool. But we can see here it's ran the diff utility and it's comparing the myfile2. This is the old version of myfile2 to the new version of myfile2, the latest copy. So it's called them A and B. The A version of myfile2 and the B version of myfile2. And then the minus is for changes that have been removed and plus is for changes that have been added. And this tells us which position it started at. So +1 and then line number 2, for example. So this is the old copy and this is the new copy of the file. And the first copy is from the last commit and the second copy is the one in the staging area. So really here in the old copy it's saying starting at line 1, and usually it will have a comma and another number. And the other number will be how many lines have been changed. But here we don't have anything, so no lines have been changed. And then we have the new copy. So starting at line 1, there has been 2 changes extracted. And then it shows us our 2 changes. So first change and second change. And we can check that in the physical file. If I open it up, first change and second change. So that's how you would monitor the differences between the new file and an old copy of the file. By the way, you can use different tools to compare files, which is a lot easier to view things. Tools such as P4Merge and WinMerge, and there's others as well, which will help you view the differences between 2 different files. A visual tool is a lot better. You'd have to integrate the visual tool with Git, and it will open it up automatically for you. So first change and second change are lines added in the new copy as indicated by the plus sign. And of course with green as well, it means new lines. Where in red, we do not see anything. Nothing was removed. So this is reviewing changes in the working directory. So this is the working directory. How do we review changes in the staging area? We can use the Git Diff command again, like we did here, but this time we use an argument. So Git Diff, let's do a -h for help. And this is only for reference. If you do Git Diff or any other command, Git, whichever command you want to use, and -h, it will give you some help and the options available with that command. But the command we want is Git Diff -staged. So the Git Diff command without any arguments displays uncommitted repository modifications by default. I missed an extra hyphen there. So this will show us the differences between the staging area and the last commit. And we can see the actual change was adding this particular line here. So this is how we compare the staging area to the last commit. And you can use Git Diff to compare changes between commits as well. So if we do git log -1 line, and let's do git diff 154 3d1c. So the very top one, the head. Actually, we can even specify head instead here. And then let's just do something random in the middle. This one here, let's do 9d0. I don't think we need the full identifier as long as it's unique. So 9d will do. Let's press enter. It is complaining about the identifier. Let's do. So here is probably a better example. So we've run the Git Diff utility, and on this line we are comparing myfile.txt from one commit to another commit, and on this line we are comparing my file. But the commit may have many other files, for example. So on this line here, we are comparing myfile2, the changes of myfile2. So for myfile, it says new file. So it looks like the file was added. But for myfile2, we can see there are changes within the file, which are listed here. Next, we will have a look at how to view all files and directories within a particular commit. And the command to view all files and directories within a commit, we use the command Git LS-tree followed by the head or followed by the commit identifier. Let's begin with a clear screen. So if we do Git LS-tree and let's do head. So we see the ID for that particular file. Files are called blobs and we see the file name itself. So we can see for this particular commit we've got 3 files. We can also on the right hand side create some directories. So let's create a directory called mydir. Maybe add a file in here. New file in my dir. Let's do a git add git commit -m new dir and file. And now let's run the Git LS -tree head. Again, if I scroll up, I can see the command in the history. So now I can see my dir, but we can see directories are called trees, where the files themselves are called blobs. So we had a look at how to unstage a file using the git reset command, but the git reset command caused some confusion, especially with the hard reset versus the soft reset. So Git introduced a new command called the Git Restore command. It's almost like a replacement command. So what we can do is, if we run a git status, and now let's create a new file. Let's call it myfile3. Again, do a git status, and let's add myfile3 to the staging area. So it's added to the index. Another name for staging area is index. But what if we wanted to undo this file from the staging area, move it back to the working directory? So for this, we can use the git restore command. So it's git restore, and if we do -h for help, we can see the options, and we've got hyphen in capital S here, restore the index. So let's try hyphen capital S and then the name of the file, myfile3.txt, enter. Not git status, it's supposed to be git restore, and that's done it. So if we do a git status again, we can now see myfile3 is in red again, so it's been removed from the staging area, the index. In this video, we will have a look at how we view our commits, so we can see the details of our commits. So to start with, we do a git log -one line, and for this we use the git show command. So we can do a git show and specify the identifier, or we can just specify head. There's also a tilde command if we wanted to go back one, so head, so the one previous commit to the head, or we can do 2. Let's go with 2 and let's press enter. So now looking at the head, we have gone 2 back, git head -2 or tilde2. We can see the commit identifier here, and this matches with this one here. So this is the head -1, -2 back, this head here. And then we can see the author and the date and time. And we can see the commit message, changed myfile2 to myfile3, and what had changed within the commit. Rename from myfile2.txt, rename to myfile3.txt. We can also see what's inside a file. So let's have a look at myfile2 on a particular commit. So if we do git show, let's go with this commit here, commit identifier, paste, and let's specify the file name, myfile2.txt, or if the file was in a directory, we'd specify the directory details here, followed by myfile2.txt. But for us, this is fine. So if I press enter, I can now see the content within the file itself. So now we can see what's inside this file on this particular commit. Or if we run the command again without myfile2, we will see what has changed for the whole commit itself. What changed within this commit. So we now see all the changes made to this commit. Again in red, changes removed from the commit, and in green, changes added to the commit. And the file it's looking at is myfile2. In fact, let's do this to make it easier to understand the git show command. I've already got 2 files, myfile and myfile2. Let me open them up. So the first one has some content inside it. This is my file, and I've put here test a line to remove on my file. So what I'll do is remove this line, and then I'll add another line, test a new line added to my file. So we have removed a line and we have added a line to my file. Now let's do the same to myfile2. So this is myfile2, another test line to remove on myfile2. So let me remove this line and let me add some content. Test new line added to myfile2. So this is very similar to myfile1. So we can see changes on 2 separate files this way. So let's do a git status now that I've made 2 changes to my file and myfile2. And of course I want to commit these changes. So git add period followed by git commit. So git commit -m changes to my file 1 and 2 again. I'm specifying again because before the video I prepared my file 1 and my file 2 to be able to demo these changes. So I prepared my file 1 and my file 2 before I started this video. So the git commit is complete and the git status shows nothing to commit, working tree clean. Now I can do a git log -1 line. and we can pick a specific commit to see what changes have occurred inside the commit. But actually, I'm going to have a look at the latest commit, the head. So it's git show head, and let's see what this shows. So the git show head, it shows the commit identifier at the very top, followed by the author name and the email address, and the date of this commit. Now, changes to my file 1 and 2 again, so this is my commit message. And we can see the changes, but notice the highlights as well. So this is my file. It's in grey because nothing has changed on this line. But notice this one, test line to remove on my file. I removed this file, so that's why it's in red. And then I had a test line added to my file, which is this one in green. So that's why it's in green. It was added, and that's why this one is in red. It was removed. And this one is in grey because nothing has changed. So this is for my file, these changes here. And then it's showing us the changes to my file 2. So it's showing the same sort of thing again. It's comparing the changes to my file 2. And again, this is my file 2. Nothing has changed. We can see in grey. And then in red, we removed this line. Added test line to remove on my file 2. And then we added a line. That's why it's in green. Test new line added to my file 2. So that's how we view changes made to a particular commit. We use the git show command. And I'm pretty sure if we add a new file, it would reflect that change as well. So my file 3, let's do a git add period and a git commit -m, my file 3 added. Now let's do a git show head. And we can see here the my file 3, the new file that's been added, it shows we added my file 3. But there are actually no changes within my file 3. We never added any content within it. Otherwise, it would have showed the changes below this section here. So that's how you use the git show command to view changes within a particular commit. Another thing is if you make a change to a file, so my file 2, let's change something inside my file 2 and save it. And then let's do a git status. And let's add the change to the staging area. We can see the change has been added to the staging area for us to review. But whilst it's in the staging area, let's say we changed the file again. So second change. Now if we do git status, what happens is that copy of my file 2.txt with the first change is added to the staging area. So it's already there, but a new copy of the same file has been tracked as well and added to the working directory, asking us to stage the change. So that's the older copy and this is the newer copy here. So that's what happens when you already stage a file and then you make another change to it. And that brings us to the end of the course. So hope you learnt plenty about Git and GitHub, and I'd like to thank you for watching.